Good morning, everyone, and thank you for those who are here in person for our day ahead market for the revised final proposal. My name is Brenda Corona here with the Stakeholder Affairs Group, helping facilitate this call, along with my colleague Isabella Nicosia, who's also online virtual participating to help us out with this call today. So this call is scheduled to be an all-day event, and we do have slides that we just posted yesterday. And for your review, we also have the paper posted as well. Here we have James, who will be leading on a few slides, as well Greg Cook, and then Gabe, who will also be leading off other slides for this meeting today. But as a few meeting reminders, we do want to go ahead and remind everyone that this call is being recorded and will be posted for conveniences purposes only. Any related transcriptions should not be reprinted without the ISO's permission. As well, we do have our technical event producer, Silas, who's online right now to take any questions, and we will be monitoring chat questions as well throughout the call. For those who are here today, we do have some handheld mics that will be utilized for the call to ask questions. Just a reminder, when you do have a question, let me know and I'll bring you a mic as well. Please be sure to state your name and affiliation before making a comment. And those who are virtual attendees, please use the raise hand icon that is located on the Zoom feature within the middle part of the Zoom call. So it's in the middle section of your screen. So keep an eye out for that. And also feel free to submit questions as well, and also add on your affiliation of who's asking the question. As we kick things off, let's go ahead and go through the agenda. Today, I will hand it off to James to go over the next few key points. But other than that, I wanted to quickly go over the stakeholder process that we have, that right now we're currently in the final proposal stage of the proposal development phase. Our next step is to go to board in May. And then I believe my team here will go over specific details of the timeline. But before we go on, I wanted to hand off to James if he wants to go over the agenda and other items that we want to express to our stakeholders today.
Okay, thank you, Brenda. So our agenda is pretty straightforward. I'll be leading the morning session where we'll go over sort of focusing in on the changes that were done in this revised final proposal and how those changes respond to various stakeholder feedback and concern that we received both in written comment and through the workshop process of the last several weeks. We'll take a short break for lunch. We'll come back and have some overflow time if needed to discuss any policy changes that we didn't get to in the morning, or if we wanted to have extended discussion on some of those items. And then around 2 o'clock, we're going to turn it over to Gabe. Gabe Murtaugh is our storage sector manager at the ISO. He's going to discuss changes specific to storage policy within day-ahead market enhancements. And then following Gabe, we'll have George Angelides walk through an Excel solver tool to help facilitate understanding of the changes to storage policy. That Excel solver tool, my understanding is will be posted after the meeting, but George is going to provide in the afternoon a little preview of how it works and what it's used for, so folks can have that to play around with. So with that said, I think we can jump into the meeting material here. Before I begin, did Isabella or Brenda, is there anything else we wanted to discuss before we move on? So one thing we wanted to talk about before we move on is sort of the timing of the paper posting relative to this workshop, and there were some concerns from stakeholders about how tight the timeline is, and ideally we would of course provide a lot more time after the paper is published to review and preparation for these workshops. We were sort of sandwiched in between two different things from going from May moving backwards, where May 17th is the board date, and so the team tried to allow for as much time as possible, both to allow the ISO team to prepare materials for the board and for the board to prepare themselves, but also to allow for as much stakeholder time as possible to respond to these changes as we could. So we decided to keep the timeline in terms of the paper posting in this meeting tighter to allow for a full 2-week comment period to the proposal. That comment period ends on April 20th. And so we felt it was a better option to have this meeting relatively close to the paper publishing, but still allow for that full 2-week comment period than to take away from that 2 weeks. And of course, we're sandwiched from the other end by the series of stakeholder workshops that we had. We had a standard amount of time to form stakeholder comments in response to those workshops. We had a matrix that we posted a few weeks ago that stakeholders were also using to help form their comments. And so to give enough time for those comments to come in, we had to sort of sandwich from the other side in that sense. So we do apologize, and we do strive to make sure there's sufficient time for review and all of these things. But sometimes the schedule necessitates a few corners cut in some places. Good. Okay. So let's jump into the material here. So again, the discussion is going to be focusing on the changes that were made from the final proposal and responses to stakeholder feedback. This presentation is not going to go through the entire proposal. It is only going to focus on the things that change so that we can direct our focus on those things. There's plenty of time and discussion allotted for today. So please do feel free to provide feedback and ask questions as we move along. I'll tend to stop after each slide because for most topics, there's one slide per topic. So I'll tend to stop after each slide to ask if there's any feedback or questions. So let's get right into it. So before we get into the material, I just wanted to sort of debrief on what has become sort of an extended stakeholder process for day-ahead market enhancements. So back in January, the ISO published what's called the DAME final proposal with the intention of taking that final proposal to the board for decision in February. The ISO decided to extend that stakeholder process in response to stakeholder comments and concern about a few elements of the design, and folks feeling like they needed additional time to work out alternatives to what the ISO was proposing and get a good sense of what the options were going forward. So the extended stakeholder process sought to address those lingering concerns. Those concerns centered around a couple of key areas around how the procurement of imbalance reserves was done. We'll talk about a little bit more about that on the next slide. The ISO solicited stakeholder presentations, and many were made by stakeholders. We had WPTF and Vistra and Southern California Edison provide presentations over this extended process, some of which provided more than one presentation, which is great. We also had presentations prepared by Market Surveillance Committee members Scott Harvey and Jim Bushnell at the Market Surveillance Committee meeting a few Fridays ago. So all in all, the stakeholder process resulted in about 20 hours of public meetings dedicated to this topic. And with really robust participation from a good group of entities, including some that had been focusing on the EDAM, but then had the time to come back into day-ahead market enhancements and catch up on what was going on in DAME. There's been comments published. I think there's 21 or 22 entities that responded with stakeholder comments to the workshops, and so the participation has been really appreciated. As part of this extended stakeholder process, the ISO published a matrix, and of course, within the workshop discussions, there's really a threshold of different ideas that were brought up, and even within some of these categories, there's really a wide variety possible within these approaches, but we did want to refresh essentially that the workshop discussions tended to center around 3 different ideas about how to proceed with procurement of imbalance reserves for day-ahead market enhancements. The first being what became termed as the nodal approach, which is essentially the ISO's final proposal, in which imbalance reserves would be procured within the IFM process of the day-ahead market, meaning that it'd be co-optimized with energy and ancillary service schedules. And the ISO would use deployment scenarios to ensure the awards are transmission feasible if deployed as energy. Essentially, to apply the methodology that's used today for real-time flexible ramping product and applying it to the imbalance reserve product. And that's monikered as the nodal approach. Other alternatives were presented and considered, one of them being the zonal approach. A zonal approach, again, there's a spectrum of options within the zonal approach, but the simplest way I think of putting what the zonal approach would do is it would continue to procure imbalance reserve within the IFM as the nodal approach would do, except that it would use zonal procurements closer, more similar to the way ancillary services are procured in the day-ahead market, rather than how real-time flexible ramping product is done. And so, another way of putting the zonal approach is you could think of it as, procurement enforcing fewer transmission constraints than would otherwise be assumed under a full-blown nodal approach. But of course, there's a spectrum of the quantity of constraints that are applied in either approach. And then what became known as the SCE approach, and I got Jeff Nelson's approval to use SCE approach as the informal name for this idea, but essentially is to, instead of considering imbalance reserves within the IFM process of the day-ahead market, we would continue with a nodal design and nodal imbalance or nodal deployment scenarios, but we would move that into the RUC process where it would be co-optimized with reliability capacity, but not co-optimized with energy and ancillary services. The RUC process today uses nodal procurement to procure reliability capacity. Nodal procurement would still be leveraged in that case. But there was a mention of a fallback option of the deployment scenarios in the IFM essentially modeling less than full deployment of the imbalance reserve so that you only, in a sense, model a portion of the imbalance reserve awards as flowing on the system. So that's a high level view of what the three approaches, and again, there are varieties of within each of these ideas, but I think this is the simplest way to categorize what was discussed. So actually, before I move to that slide, I'll just mention that the ISO did publish a comparative matrix with our perspective of the trade-offs between these approaches. That document is available on the stakeholder initiative webpage. I will note that WPTF in their comments did provide a redlined version of that document. So if folks wanted to see a different opinion or different perspective on that document, please do look at WPTF's comments to the workshop material and you'll find that attachment. So quickly, a summary. So after the series of workshops were done, stakeholders were given the opportunity to provide written comment. I will note that in the paper itself, at the very end in Appendix B, the ISO provided its perspective of a summary of each commenting entity's perspective in the appendix there, which hopefully folks find that helpful if you wanted to find a more abbreviated version of the stakeholder comments to get a general sense of how folks responded. That may be a more streamlined way to do that than to look at the full comments. And of course, if you're interested in the full comments, you can look at that. The Appendix B, I think, captures everybody that even to this day, I looked this morning, I think everybody that has publicly posted comments is represented in Appendix B as of today. So just so you're aware, if there are entities that comment after today or posted after today, those won't be represented in that appendix. I think overall, in the comments came back with mixed feedback, and there's still a wide variety of agreements and disagreements on certain elements of the design. There continues to be a theme of disagreement on whether a nodal or a zonal approach is preferable. So we did want to highlight that part. There continues to be disagreement on whether a downward imbalance reserve product is needed. We had a few entities that questioned whether or not the data support a downward imbalance reserve product, and then had a few entities who, you know, unlike in previous comments, I felt like there were actually a few entities that commented in support of a downward product and felt like, you know, for their particular region or BAA, that a downward product might be something that they would be really interested in having as part of the market, if, you know, as part of the EDAM market offering. So I found that to be interesting. There were several suggestions of sort of alternative design ideas that sort of kept ourselves within the framework of the final proposal, which basically means that you have continue with an IFM and a RUC process, but there were various ideas about how you might move the imbalance reserve around between those two processes. And so PG&E, Edison, LADWP, Department of Market Monitoring all provided some comments about how that might move around. You know, I will add that there are like folks like WPTF and Vistra that have other alternatives. This goes beyond sort of those other alternatives that we discussed in the workshops, but you have ideas about like splitting the imbalance reserve into two products, potentially moving all of the imbalance reserve into RUC or a portion of the imbalance reserve into RUC. And so there's various flavors of how that works. All of those entities seem to advocate for at least moving some portion of the imbalance reserve product into RUC. But then there were other commenters who disagreed with the inclusion of imbalance reserve into RUC. So that became another theme that was interesting in the comments. There were several, I felt like several entities expressed concern about the 15-minute ramp requirement that's associated with imbalance reserve, and that gained a lot of traction after the MSC meeting a few Fridays ago. And there was also concern expressed about the costs associated with the congestion induced in the deployment scenarios and what the potential cost of that might be. Other frequently commented items were on the imbalance reserve demand curve, flexible application of constraints or the desire for flexible application of constraints, continued concerns about market power mitigation, and also concerns about the uncertainty distribution in the deployment scenarios. So again, please do, if you're interested, if you want a streamlined version of these comments, look at Appendix B of the proposal. Otherwise, you can find all of the entities' comments on our stakeholder webpage. Any questions so far? Okay.
We do have a question over the phone.
Okay.
This is Sarah Thomas with the CPUC. I just wanted to point out that the CPUC submitted pretty extensive comments in this last round as well.
Thank you, Sarah. Yeah, and I looked for those comments on the webpage this morning and I didn't see them posted yet, but
yeah, they're there. I found them.
They're on there?
Mm-hmm.
Okay.
Yes.
Thank you. Okay, so thank you for that. Okay. Okay, so that's going to wrap up our discussion of the workshop, debriefing of the workshops, what was discussed, and the summary of comments. We're going to move on into the actual material in the proposal. Okay, so again, I think the cadence will be that I'm going to, most of the topics are going to be contained within one slide. So I'll go through each slide. I'll pause for questions and feedback on each item. So hopefully folks found it helpful that the proposal does highlight areas that had changed in the proposal using red text in the document so that folks could isolate their review of the document on the things that changed if that's what was interesting to them. There also is in section 1 of the paper a summary of what I just went through in terms of the stakeholder comments and a summary of each change, which you would find more detail in the body of the document, but section 1 does summarize each of the concerns such that if you're really just focusing in on that, section 1 is where you would want to look. Okay, so the first thing we'll discuss is flexible application of constraints in the deployment scenarios, and this became something that a few entities identified during the workshop process and during the comments as something that would be valuable. And the ISO team discussed internally whether something like this was possible in the implementation and decided that it was. And so I do want to highlight that this is more of an implementation style change than really a policy change, and I'll sort of discuss why that is. But in a general sense, the proposal it does continue with sort of the nodal procurement of imbalance reserve, but does make some modifications, some of which are on this slide and some of which are in preceding slides. The punchline here being that the ISO plans to implement functionality that enables for flexible activation and deactivation of individual transmission constraints, not just groups of transmission constraints, as is being applied in the flexible ramping product today, but going a step further than that, more granular, in that you'd have the ability to sort of turn on and off individual transmission constraints for all BAs in the EDAM, specifically in the deployment scenarios. And sort of what that does is it builds within the software an architecture that accommodates a range of nodal and zonal outcomes. So this type of design or this type of implementation can support a full-blown nodal approach with every transmission constraint enforced to the T. This type of design can also go all the way back to the other side, where if it were found to be desirable to move towards fewer transmission constraints enforced or more of a zonal outcome, then the market software is flexible enough to do that. So basically because we're able to accommodate this range of outcomes, we can sort of build the software and let the market testing, market simulation, and also the operational experience once DAME and EDAM are implemented to sort of guide us on eventually finding the sweet spot in terms of how many transmission constraints are enforced in the deployment scenarios, and sort of builds upfront into the software the ability to do that. Where the alternative being that if you were to say build specifically for a full-blown nodal design, or build software specifically for a full-blown zonal design, you'd have to come back to stakeholders to re-stakeholder the building of additional software to support those changes. It would be there would be a delay in that process. We think we can more flexibly accommodate a range of outcomes with this type of change. So what this modification also we think does is address stakeholder concerns about computational performance. And so there was a lot of discussion about that in the workshops, to what extent you're going to add additional constraints into the IFM. The deployment scenarios may be computationally heavy. This gives us the ability to, if we're in market testing, market simulation, and seeing big impacts on optimization and computational performance, not being able to get the market to solve on time in specific instances, you can dial back the number of constraints that are forced on a much more granular level. The other thing that there's also a market impact potential to this, where there was data presented where the ISO has a significant quantity of internal constraints that bind on a relatively frequent basis, but for EDAM BAAs that may not be the same frequency or quantity. And so one example could be that I'll pick on PacifiCorp. You could imagine that if PacifiCorp transmission system had, I'm going to make up a number, but let's say 500 transmission elements that were monitored as part of these transmission constraints, but you really only, after the data comes out, you really only see 5-10 of them ever frequently binding or binding on any consistent basis. And you were concerned about optimization performance or market performance of monitoring for 1,000 constraints when you only really need to enforce maybe 5 to 10 of them. We can come back into the software and identify what constraints are critical and basically turn off the constraints that are never binding. It would have no impact almost no impact on the market results, but could lead to a much more efficient optimization performance potentially. And we think that's really valuable. Finally, as I sort of teed up, this type of process could be a collaborative process with EDAM BAs to identify the critical constraints in each BA to enforce. Of course, one other thing before I pause for questions is the market testing and simulation, is my understanding, is will test for sort of the full-blown approach, which we hit the gas all the way to the floor, see how well the optimization is performing with all of the transmission elements identified and monitored for constraints, to see even within the testing itself whether we need to peel back on that. So hopefully that makes sense. I'll pause. Actually, I just thought of one other point that I thought I'd make that maybe head off a question is that we do anticipate that this activation and deactivation of constraints would be relatively static, not something necessarily that would change relatively frequently. We envision the process being that, the ISO would have metrics and performance discussions about how well this is working, present these to stakeholders in various forums, and come back to identify if we want to change the set of constraints that are enforced at any given time. We could do that, but it wouldn't necessarily be something that was done on a daily basis where market operators every single day are looking at the constraints to enforce and having some sort of criteria to do that. So it would be a relatively static set of constraints at any given time with some time. It would take some time to accommodate a change in those assumptions. Okay, I'll pause for questions. And there's at least 2 in the room before we go to the phone.
Testing, testing.
Hi, Steve Keen from Edison. I just wanted to follow up on that because that's an awful lot of control that you're going to have, and I'd like to know, first, it seems to me you're kind of going about doing it backwards. It seems like you'd want to start with the fewest and then add constraints as you go on to make sure that it's not causing problems in the market. One of the things that we brought up numerous times is the phantom congestion and the potential impacts on market prices. And if you're enforcing all of the constraints right away, it seems more likely that that would happen. So I think, we tend to think that the way to do it would be, if you're going to do this, set everything kind of at minimum levels initially, and then increase it as you see that it's working and not messing up the market. But the other thing that I think would be important to us in the proposal would be to see laid out how you're going to change these things. I mean, clearly, if you're talking about changing them like that, this is not going to be in the tariff. It's going to be somewhere else. But what's the process for adjusting and changing these? What's the process for figuring out initially what you want to, where you want to set them, and then what's the process going forward for making changes? And it's just, I get, it's kind of like what you're saying is just trust us, and we'll let you know what we're doing. But that's we're not exactly comfortable with that right now.
Thanks, Steve. So I sort of heard 3 questions in there, which I'll try to respond to as best I can. So first is the sense of it gives the ISO a lot of control. And I think that as a valid concern, what we would have to think about is, and I think that's also sort of a FERC risk too, in the sense that our tariff is going to have to build in process for not allowing the ISO. We want some flexibility in this approach, but of course we can't just arbitrarily. Go ahead. Yeah.
I get one other question that just occurred to me with this.
Sure.
Is in the various BAAs, like the other EDAM BAAs, who decides on this? Is it going to be the CAISO, or is it going to be the BAA operators that decide which constraints would be enforced?
Yeah, that's another good question. So I'll get to that. I'll get to that one at the end. In terms of just the amount of control that's good to ISO, we would have to build in, and admittedly, this idea is relatively fresh, and so we haven't had sufficient internal discussions to decide, what the tariff language might look like in response to giving the ISO some flexibility in this regard without sort of, allowing the ISO to do whatever it wants when it wants. And I'm sure FERC would not agree to those types of changes anyway. So we would have to build in boundaries to this type of control. That's for sure. In terms of enforcing the constraints right away, I made that comment in relationship to the market simulation and testing. In that my impression is that by going with that method, you can identify whether the concerns about excessive congestion and other things are realized in those scenarios. And if they are, you can sort of dial back, turn the knob and dial it back to find a place where sort of the market performance is at a level where you would want it to be, but enforcing as many constraints as possible gets you what we think is the desirable result of having reserves that are, at least when they're procured, as deliverable as possible. And so we think that the sweet spot would be identified by sort of going strict down rather than less strict up, in the sense that we want to sort of monitor as many transmission constraints as possible without these unintended impacts on, or excessive impacts on the market, excessive impacts on computational performance. And go ahead if you want to respond to that one.
Yeah, that would be, I mean, I agree in the market sim, that makes sense. But I'm not sure that the market sim isn't going to catch all the potential stuff that could come up in real time. And I think that's one thing that concerns. That's why I think even if you do that in market sim and it looks okay, then I think when you actually start putting it into the market, it would seem you'd want to do it the other way just to be safe. Because it's easier to add things in, and I'll just stop with that.
Yeah, so you make a good point too, which we'll discuss, is that the market sim won't catch everything, and there's even an element where it seems that it might be desirable in some entities. It seems that it might be desirable even to market simulation is going to test the day-ahead market run and results, but there's an element too of actually potentially taking those simulated results and comparing it to the real-time actuals to see different things. Of course, it'd be simulated data compared to actual data, but bringing that up, my point being that you're right that there's going to be dynamic changes involving in the market when this stuff is actually put in the market, where people are going to bid differently. Potentially, they're going to participate differently in the market in anticipation of these changes, where even comparing simulated data to real-time actuals won't reflect the true reality. So there is a little bit of a wait and see approach in terms of having the market or this implemented in the market and seeing how it actually performs in real time. And I can't perfectly anticipate where we would be in terms of the number of constraints that are enforced when we put this in, but I would imagine we would take a cautious approach similar to FRP, where if we had concerns about performance, we would start slower. And so I think my point is just being that the market simulation may be able to inform how far we go. And I would also think that our continued experience with FRP would also help in informing how far we go in that. Go ahead if you want to respond.
Well, I think to me, FRP is a lot different because the uncertainty is much smaller and the state of the grid is known. One of the things I think that you should be looking at either before or at least certainly during market sim is when you set up these, that you do the day ahead optimization and you're looking at those deployment scenarios. How likely is it that that's what actually develops? And I'm not talking about, the fact that it's the 97.5%, so it's not going to get there. But what I'm thinking is even if, you actually get to the point where it's 97.5% of the imbalance is realized, I suspect that it's not going to necessarily show up where you think, but also the grid is going to be very different. The generators that are on aren't going to be the ones you projected because, things change in real time from whatever. And I guess that's one thing that would be interesting to me. If you're going to set up that, look at all those transmission constraints when you're picking the resources, how likely is it that that's actually a good estimate when you get to real time? Is it close, or is it, are we just putting in kind of false level of precision? And if it's that, then I think that's one of the reasons that we're questioning doing the deployment scenarios to that level and looking at all that is, we look at what's going on and, we've talked about, and a number of people have mentioned the way that you're spreading the imbalance may not match what really shows up. So you've got, that's not accurate. But I think there's also the chance that, you know, the resources that are online coming into that particular hour may be different than what was estimated day ahead. And it's, you know, if those aren't, if we're not getting that accurate, are we actually, you know, making matters worse rather than better, or at least not doing anything? And, you know, if we're raising the prices because of this phantom congestion or the other congestion, and it's not really doing anything because when we get to real time, it's all different anyway, are we gaining anything?
Yeah, and I agree. Those are all, you know, valid concerns that hopefully the market sim would be set up to explore. It wouldn't be able to provide full concrete evidence, but at least, you know, maybe at least the light bulb could go off whether or not there might be an issue. I wanted to touch on two of your other points. The process for changing and adjusting the parameters. Again, this is a bit of a fresh idea, and I think the tariff and other processes would have to be developed in order to understand, fully flesh out how that process would work. I think that, again, at a high level, the two basic things you'd be looking at are computational performance, whether or not that's taking a major hit. That's something that I think the market simulation would be able to identify pretty quickly, whether or not the enforcement of all these constraints leads to poor optimization performance. Second thing would be in terms of just market performance, looking at anomalies in the results, potential. One idea could be if you have transmission constraints that have a very small amount of binding flow, but for some reason result in a really high amount of congestion costs, where you could like greatly reduce the amount of congestion costs by not enforcing this specific constraint, which would, you know, make your reserves 98% deliverable just by ignoring this specific constraint. I think those are the sort of trade-offs you'd be looking at. And I think, you know, it may be sort of unfair, but I would think we would have to punt the question a little bit towards operational experience and having stakeholders help us identify where the sweet spot is and the trade-offs fall between these things after there's some actual operational experience. So I would imagine there'd be some amount of, a great amount of periodic review, communication to stakeholders, reevaluation of how these things are working, so that we'd come back and reevaluate. And then a similar question about who decide, if you have EDMBAs, who decides? Again, that process would have to be figured out. I don't have an answer to that, but the high level answer would be, it would be some sort of collaborative process where we'd probably mimic other sort of market procedures in terms of getting that handled. So there's another question in the room before we move to the phone. But actually, Brian, can I just ask who from the California ISO is on the virtual panel, just in case?
We have Anna McKenna, James Lynn, Becky Robinson, and David Zutlow, George Angelides, Jillian Hong, and I think and John Gooden.
Okay, no problem. And I thank them for joining in. And so if they want to add on to anything I'm saying, have them raise their hand so we can get them into the queue, because I can see Greg and Gabe, but I can't see them on the phone if they want to add in. Oh, Greg is going to add on. Okay.
Yeah, I just wanted to add on to, you know, a couple of Steve's comments. You know, I think we need to be careful when we're talking about phantom congestion, because I don't really think it's phantom congestion when we're reserving transmission in the day ahead time frame to ensure that we have potential deliverability for uncertainty that's going to arise in the real-time market. You know, so I think we need to be careful about our language there. I think it's more about, you know, how accurate is our deployment scenarios, and, you know, are we seeing the imbalances arising where we think it's going to? And, you know, it's a balance as well. It's not just whether we're seeing congestion costs caused by imbalance reserves, but it's also, are we seeing the deliverability from the resources that we're procuring the imbalance reserves from when we need it. So it's, you know, it's a balance of that market impact as well as the reliability benefit that we're trying to achieve from the product. So, you know, I think we need to keep that in mind, and that's what we'd be looking at. Again, making sure that the market's not coming up with inefficient outcomes, but that we're enforcing enough constraints to ensure that we're getting those reliability objectives that we're after.
And if I may add on before moving to the next question, there's another a similar piece to that in terms of the distribution of the uncertainty, and we cannot be certain about how the uncertainty will develop. That's just the way it is. And in any individual market run, the uncertainty is very unlikely to show up exactly how it's distributed in the system in any individual market run. So what we would have to look at is to analyze over time, whether on average the uncertainty as it's distributed across the system sort of materializes on average. And if folks are wanting certainty about where the uncertainty is going to show up, it's just not something that's going to be possible. So just something to think about when we're thinking about how we're going to distribute the uncertainty. It's sort of an average look or some reasonable estimate of how on average that's going to play out. Go ahead.
Hey, James, Brian Thaker with Middle River. I can't not acknowledge that we just had a comment about the uncertainty of uncertainty. Positively Rumsfeldian, but that anyway. My comment is, understanding that we haven't developed the process for notifying the market when the ISO starts enforcing, different sets of constraints. I just commend the ISO for the approach they took with scheduling run parameters to make, notification within 1 business day, and encourage you to look at that, at least as a timeline. My question is, since you invoked FRP was launched with a subset of enforced constraints. Have we moved beyond that yet? And again, can you just outline in general terms what the ISO is looking for when it makes the decision? Is it simply a trade-off between congestion and performance of the software? But what's going to be the ISO's underlying philosophy is to decide when to move to a different set of constraints?
It's a great question, and I don't know, but I didn't hear Guillermo's name on the line. But if anybody on the ISO team on the phone has an answer to that question, please raise your hand. George Angelides is going to respond.
Hello, this is George. Can you hear me? Hello?
Yes. Yes.
Oh, okay. Yeah, so of course it's driven by performance, but also by the need of having a specific constraint enforced, because it's important for operations, for the reliability of the grid. So there's an evaluation on it, and there are different ways of getting to a solution that has this constraint addressed. It could be a preventive contingency constraint, or it could be a base case constraint, or it could be handled with a nomogram. So depending on what the situation is and how critical is addressing the constraint, obviously it's something that we will evaluate. We are always concerned regarding performance, adding a lot of constraints to the problem, but we want to strike the silver lining there of having a secure solution without compromising performance to the point that the solution becomes unwieldy. So it's always a trade-off and an ongoing evaluation in that regard.
Yeah, we can follow up with exact where we are on the spectrum today.
Yeah, Brian. I mean, the latest information I had was that the plan was to have all the constraints in by the end of March, but I'm not sure if that occurred or not. So I'm not certain on that. But okay. It's still early. Even if that was the case, we probably only have a week or so under our belt. But I think it's a bit of a different situation with flexible ramping product. In that phased implementation was more making sure we're putting pieces in one at a time, making sure everything's working right, being able to evaluate impacts on the optimization, those types of things before we go to the next step. Whereas there'd be similar concerns here, but here we're also looking at that trade-off between cost and reliability and those types of things.
Yeah, thanks, Greg. I'll just comment. I think it was a bit of a surprise when the ISO rolled out in March that it was only enforcing a subset of constraints. Not an unpleasant surprise, but I think it was just different than what we expected. So I just encourage you guys to be really communicative about, what you guys are going to do on the onset of this thing, and so appreciate it.
Isabella, can we go ahead and take those 3 hand raise? Or Silas?
Yeah, let's go to Lindsay.
Hi, Lindsay Schleckaway from NV Energy. Can you hear me?
Yep.
Okay. I just wanted to first say we really appreciate that you are considering the computational performance of the product. And I was wondering if this is something that we should be concerned about. This was something we commented on. And I just don't have any idea how long this would take and if it would delay market results at all for the day ahead market.
I may need George's help if he can provide some context about what the process might look like. There has been some history of the ISO identifying computational performance issues relatively quickly in the process, and so I would imagine that if there was at least a big red flag after the software is delivered and there's issues with the vendor, that could be identified rather quickly, but maybe George could elaborate on what that process might look like.
Yeah, so what we usually do is when we get into the development stage with the vendor, there is also an ongoing process during that phase to measure performance, evaluate performance, and start addressing it. So at the time that we have the code delivered for functional testing, most elements of the performance have already been addressed. And, this is more art than science. It involves techniques that the vendor can implement in their software. And it's a wide variety of elements that we have applied in the past, like hot start between passes, and now we have to coordinate in ADAM 6 passes. So there's a lot of work to be done to make sure that we publish in time. Originally, we were positioning the market to publish by 1 p.m. We may revise this to 2 p.m. depending on how the preliminary results of our performance evaluation goes. And of course, we'll keep everybody apprised in this process. There's a lot of tuning that can happen to get us there to meet these requirements. Sometimes it involves relaxing some of the constraints, the number of constraints in the critical set, which is typically, they're included if they're, at 85% of the limit. That 85% is a configurable parameter. There are a lot of other things that the vendor can try, and it's always a big effort to make sure that performance allows to meet the time requirements. Normally, we don't really come out and say exactly what is going on. Some of those are trade secrets, but we will apprise the stakeholder community on how this process goes once we get into the development phase where the vendor will start building the software and we'll have the first results of unit testing.
Okay, thank you very much for that explanation. I was wondering which process should I pay attention to find out when the day ahead results will likely be published if it's not 1 p.m.?
I expect that we'll have some market notice or something similar to communicate with stakeholders the target for the publication time.
Okay, thank you. That's all I had.
We do have Alva from PG&E on the phone. Let's go ahead and unmute him first.
Good morning. Can you hear me?
Can you speak up, Alva?
Hello, can you hear me?
Yes.
Great. Sorry, I might have the volume wrong on this. Just before getting to my original question, comment that a 2 p.m. Market publication timeline is pretty different from a 1 p.m. one, and you'll want to consider that carefully, especially with respect to EDEM participants who might be on mountain time. There's this whole issue of the deadlines for DR programs that you'll want to consider in extending that publication timeline. The other comment I wanted to make is that these, adding in or subtracting transmission constraints from the deployment runs will at least indirectly affect congestion in the energy market and hence the value of CRRs. And so I'm guessing that whatever controls there are on that now will need to exist in this approach as well, since those who purchased those hedges or have them are presumably wanting to preserve the value of those hedges. I had just a question about the logic of this, which just to take the extreme case, if you had no transmission constraints, or suppose you only had the transfers at the ties, say in the NP-SP constraints, almost like the zonal constraints, would you still, would the algorithm essentially automatically still solve for the deployment scenarios, or would you have some, is there some level where the deployment scenarios are no longer material and don't have to be solved?
So George can piggyback on my response, but I think that deployment scenarios would run the same way. You'd have full, well, two concepts. You'd have full awards, so you'd still meet the entire imbalance reserve requirements up and down, and you'd still use that through deployment scenarios in which the deployment scenarios will model supply and demand injections and withdrawals as we described during the workshops, except that the only transmission elements is monitoring are those few subsets that you mentioned. George, is that an accurate way of describing it?
I just want to cover the other aspect of the question that you may end up not having to enforce the deployment scenarios. They're integral to the IFM formulation right now. So even if no constraints happen to be binding at the solution, we will still have to run the deployment scenarios because this is the mechanism of how we will procure the imbalance reserve awards. I mean, they're really together, those two. So yes, we may have some process where we enforce only the most critical constraints that we consider in advance in the deployment scenarios, but they will always be part of the formulation because it's the way that you will procure the imbalance reserve products. It's done through the deployment scenarios, even if there are no constraints binding there. So I hope I answered that question for you, Alva.
Yeah, but I mean, the deployment, are you saying that basically the amount that's procured of the targets is going to be determined by the deployment scenarios? I'm not sure if I understand that, but if that's the case, is that what you're saying?
Yeah, let me try to draw a parallel here. As you know, we have this power balance constraint, which balances supply and demand in the base scenario. And you have that constraint also in the deployment scenarios where you now add the imbalance reserve awards on one side and the imbalance reserve requirement on the other side. And it becomes now essentially the procurement constraint for imbalance reserve is like having a power balance constraint for energy and capacity in the deployment scenario. So even if you don't have any constraints, formally enforced in the deployment scenario, to have a general formulation that can handle constraints and the power balance is coming together as a deployment scenario. So you'll always have the deployment scenario so that you can procure the product. Now, whether you have binding constraints or not, that can differentiate the locational price of the product at different nodes. It can affect on where you're going to award imbalance reserves, but it's still all done within the deployment scenario.
Right, right. Okay, that makes sense. I think I thank you for that clarification. I guess those deployment scenarios would be much easier to solve for than the full transmission, full set of transmission constraints. But I think that makes sense what you just said. So thank you, George.
You
Listen, I just want to confirm something. I'm pretty sure I understand this, but when we're talking about what constraints, limiting the constraints, that's only in the deployment scenarios, right? That's not in the, is it the base case?
That's correct.
Thanks.
Okay, we'll move on to the next slide. So this is a related topic. We think that this change in the change proceeding sort of work together in a sense to allow for a lot of flexibility in terms of the previous slide discussed specifically which constraints are enforced. This is getting more into the quantity of imbalance reserve that is seen as flowing on the system in response to those constraints. So basically what the ISO is considering here is to create a tunable parameter for imbalance reserve deployment in which we could define the proportion of awards that are deployed with resulting flows in the deployment scenarios. And of course, this is piggybacking on a suggestion from Southern California Edison in the workshops for something like this. Now, before I get too much, I'll finish the slide, but I do want to bring up the fact that what these slides are missing, and probably I should have led with, is that the ISO is continuing to procure or propose to procure the full imbalance reserve requirement within the IFM and not have any of the product procured within the REC. And that a combination of these products or a combination of these changes mitigates the need to move the product either in part or in whole into the REC process. So do keep that in mind as we're going through these changes. Back to the tunable parameter, here's a simple example here. If the parameter, say, is set to 0.5, that means that only half of each imbalance reserve award would result in a supply injection onto the system, and half of each imbalance reserve demand would result in withdrawal from the system. And that's what would be modeled against transmission constraints in the deployment scenarios. So you essentially take every award and you divide it by 2, and that's the quantity of flow that you would see on the system. You take every piece of demand, divide it by 2, and that's where the product sinks. And of course, that parameter can be adjusted. It can be 0.9, it can be 0.95, it can be 0, which effectively makes it irrelevant. But in any case, it would be a tunable parameter. Again, this modification in conjunction with the previous one seeks to mitigate concerns. This one not so much specifically on optimization performance, more on the market performance in terms of if you're seeing excessive congestion costs in the deployment scenarios, could you tune back this parameter to achieve a relatively high level of deliverability in terms of how the model is working, but greatly reduce the amount of congestion congestion cost that's being put into the deployment scenarios. That's essentially what the trade-off would look at. And so now in terms of testing, just as in this previous example, the ISO would plan to initially set the parameter to 1, which essentially is the same thing as saying we would start with in the market sim and testing to model full deployment of the imbalance reserve so we can see what the impact is on the relevant metrics. But again, it can be flexibly adjusted if needed after the market simulation or operational experience justifies the need to dial that back. A couple of key notes here. This process would not affect the scheduling limit constraints for EDAM transfers, and so it would My understanding is that EDM transfers are done. Scheduling limits are not a flow-based constraint, and so it would not affect that process, which is, I think, a positive thing that mitigates. Actually, in the paper, there was a sentence that said something about concerns about EDM transfers that after some more thinking, after we published the proposal, we think that sentence might be irrelevant now. So that's a positive thing. But again, in conjunction with the previous constraint is allowing for some flexibility to dial back the impact of the deployment scenarios on congestion and market performance if the need arises to do that. I'll pause for questions or feedback on this topic.
James, we do have a question in the phone line. Silas, can you bring up the audio bridge for that question?
Yes, the caller is unmuted.
Great, thank you, and thank you, Brenda. This is Kathleen Colbert from Vistra. Can you hear me?
Yes.
I actually raised my hand to make a request to the CAISO back on when we were discussing with Lindsay's question. So I really appreciate Nevada bringing this up. I don't think it's gotten quite enough discussion on what the impacts to the market timeline are going to be under an EDAM. Kind of irrelevant for the, yes, the day ahead market enhancements is proposing some new iterations, is proposing a second MPM, is proposing multiple iterations of a power flow. But even if you set that aside, EDAM also introduces a resource efficiency evaluation and a greenhouse gas pass. So, I mean, it is clear that there will be market timeline changes under EDAM. And I don't believe we've had a robust discussion on it. I think a process, like defining what process we're going to have that discussion is really useful. And so I wanted to make a request to the CAISO to include a market timeline impact discussion in the tariff workshops that are scheduled to start, I believe on the 10th, but there's a few of them scheduled in May as well. I think that would be a perfect process. Most of the open questions about EDAM were deferred to that process, so that feels very appropriate to Vistra. So that's my request.
Thank you. We can certainly consider that. Thanks, Kathleen.
Yeah, of course. I mean, we understand that it's going to be extended. We operate a large combined cycle unit, as I think some folks know, but I'll reiterate. So the gas nomination deadline for the evening nomination cycle, which is around 4 p.m. Pacific, is really critical. And we need to have a robust discussion about that so that we can manage and discuss gas management issues under an EDAM. So I just wanted to add that extra context to reiterate how very important it is that we have a discussion about it. Thank you.
No more questions in queue. Oh, wait, James, sorry about that. A hand just raised at this time. Let's go ahead and take J.K. Wong.
Hello, this is J.K. Wong from PG&E. Can you hear me?
Yes.
Hi, James. Thanks very much for explaining this idea. It's very interesting, and also appreciate CAISO's efforts of making the whole thing more tunable. For the tunable parameter, I'm trying to get some intuition of what's the idea behind this. It seems that when you have a parameter set last one, you are procuring to the full amount, but want to ensure a percentage of deliverability. Is that a right way to think about this?
I think that's okay. I think that's the right way to think about it. Yeah. So if you're essentially and let's take the example here. If the parameter is set to 0.5, essentially you take all the supply awards and cut them in half, and that amount of flow is what's seen on the as evaluated against transmission constraints. And so maybe it would be appropriate to say that in that instance you're modeling half of the supply of the award against transmission constraints and the other half not against transmission constraints.
Okay, so can you share some insights, like in what occasion we imagine that you want to set a parameter higher, and for the other times you want to set it lower? Let's say in what occasion you want to set it to a lower end of the value?
So I think bullet 3 explains, I think in the market simulation, we'd start by setting the parameter to 1, which is the same thing as saying full deployment of the reserves. And what I think we would monitor for is to look at congestion impacts in the deployment scenarios to see what's the volume of congestion that occurs outside of the base scenario and specifically within the deployment scenarios, to see what the related congestion cost of those binding constraints in the deployment scenarios are. One metric that may be interesting of looking at is if there are constraints with which, as I said in the previous slide, if there's constraints with which have relatively infrequent constraints that bind, but when those constraints do bind, result in really high congestion costs or congestion offset, then maybe that might be something that would signal that, okay, well, in those instances, you're getting a relatively low reliability benefit by enforcing that constraint because it's only binding a very small fraction of the time, but you're paying an outsized amount of congestion costs when it does bind. So there may be a trade-off there of saying, well, if we were to ignore this constraint or we were to deploy less of the reserves just in general, we can sort of still maximize the potential for procuring reserves that are not behind constraints, but at the same time, weighing that against the potential cost of doing so. Generally, that's my intuition about how this thing would be evaluated. But again, the process would need to be thought about more to get out that question.
Okay, and just to confirm, when you set a parameter to 0, I know it's not, you're not going to, but if it is set to 0, it's equivalent to you deactivate this constraint as the slides before, right?
It would be equivalent to essentially deactivating all transmission constraints, is my understanding, because essentially what it's saying is even though the constraints are active, that there's no flow resulting from the imbalance reserve awards, so there'd just be no difference.
Right. So it will be the same as before. Okay. Yeah. Okay. I think this is very helpful. And just one thing, I do want to mention that all of these tunable features is going to interact with the CRR process. I understand it's a cost location, but the utilities do use the passive values to determine which pairs to nominate in next round. So it's something to consider, like how to communicate the process with us more clearly.
Yep, that makes sense. Steve has a question in the room.
Testing.
Hi, Steve Keen from Edison. I'm just thinking about this, and you talk about with like a 0.5, that would mean every resource was assumed to provide half of the power. I think we might need to talk about that a little bit, because I'm not sure that's how, if we're talking about the fact that we don't want to be at a 97% deployment, we want to be at a 50% deployment. I don't think that the outcome would be just, okay, we're going to take half from each of the resources we've got. It's possible that some of those, the congestion would allow, you'd take more from one resource and less from another. I think it also strikes me that at least some of that would be decided by the price of, what they're putting up for energy to decide where it would be. And I think we may need to put a little bit more thought into how that would work. I mean, it's possible that the way you described it would be the best way to do it, but there may be other options available as well that we might want to try and look at to see how the congestion would actually arise, or which one of those resources would most likely come online.
Yeah, so certainly if there's, if we can consider alternatives that get at the same sort of an intention, but in a maybe perhaps a more efficient way, we can certainly consider that. So, any other questions on the phone? Okay.
Okay, let's go ahead and queue up Stuart Kelly.
Hey, James, just real quick, on the day ahead run getting published at 2 o'clock, can we look at the advisory runs starting, the second advisory run starting at 8 a.m. and the day ahead run at 9 a.m. So that we can still target a 1 p.m. publication? I understand existing day ahead participants, that is a one-time change in all their processes, but can we look at the trade-offs there? Because given what Kathleen said and Lindsay's saying, you know, you've got mountain time considerations, gas purchase considerations that would be, it's an ongoing daily thing that those folks need to deal with, versus a one-time change for existing day ahead participants. Because I don't think you have a 6 a.m. run for advisory. I don't think any changes between 6 a.m. and an 8 a.m. run, so plenty of time to do those, and it's intensive market run that you're actually doing for the advisory. So it would be good just to look at that and see if it makes sense.
Yeah, thanks, Stuart. I'd imagine that any decision that's made on this matter would involve consideration of stakeholder feedback. And it's an interesting idea, maybe to, instead of moving the market 1 hour later, if you could achieve the same thing by moving the market 1 hour earlier and not have conflicts with some of these items that you mentioned, maybe that would be desirable. But in any case, I would think that, you know, stakeholder feedback would weigh in heavily on the decision how, if necessary, that needs to be done.
Thanks.
Thank you. Okay, so we'll move on to slide 12. So this is not a policy or implementation change to the proposal, but we did want to highlight this here because it is also in direct response to discussions that we had at the workshop and brought up by stakeholders in the comments. The ISO will commit to evaluating the need to add a layer of regional uncertainty into the nodal uncertainty distribution. So when I'm using the word layer, I'm referring back to flow charts that were made that showed how the ISO moves from a BA level requirement, separates it into 3 buckets between load, solar, and wind, and then from each of those buckets distributes down to their respective nodes based on some distribution assumptions. So a regional uncertainty layer would likely be that a consideration of still separating the uncertainty into the solar, wind, and load buckets, but then within each of those buckets maybe have a regional element where solar in specific locations would get a different proportion of the uncertainty within that bucket than others, and then from there distributing it down to the zones within that region. That's me sort of talking out loud what the process might look like. Of course, this would be something that I would imagine be stakeholdered, and more efficient processes might be discovered. But in any case, I hope it just gives a picture about what potentially would be included there, because the concern is pretty clear that the stakeholders bring up that the ISO's approach for distributing the uncertainty in the deployment scenarios doesn't account for the differences in uncertainty across locations. And so, you know, we would have to evaluate whether or not this concern is realized and is needed to be addressed. And then if so, we would develop some policy to make that change. A simple example, this was brought up in the workshops, but you could think of it as 2 variable energy resources. Let's call them 2 solar resources, where if they have the same forecast, they will get the same uncertainty distribution in the current process. But if those resources have the same forecast but are in climate zones that have different inherent uncertainty between them, it may be more appropriate to assign more of the uncertainty distribution to resources in the more variable climate. So that's a good suggestion, not within the bandwidth of us to solve before the May board, but something we'd commit to looking into. The idea here being that there's potential for, if this would result in a more accurate uncertainty allocation, it could improve market efficiency by allocating the actual variability of the resources and load in different locations in the deployment scenarios. So this sort of process would be looked into in the interim between now and when DAME and EDAM are going live, with the intention that if this sort of process is needed, it can be implemented shortly after DAME and EDAM are go live in spring of 2015. I'm sorry, spring of 2025. I'm 10 years behind. Okay, I'll stop for questions or feedback on this item.
We do have a question over the phone line, so if we want to go ahead and unmute Dan.
Hi, this is Dan Williams from the Energy Authority. Can you hear me okay?
Yes, I can.
Okay, good. Thanks. So this kind of goes back to the tunable parameter piece as well, but applies here. So I wanted to wait to ask on this slide. But when you're thinking about the tunable parameter, are you thinking about that as a single parameter for the entire EDM footprint? CAISO BA plus any external BAs, and for all hours, days, or would it be a BA specific and or maybe specific to certain constraints or subregions or times of day? And if it is different for different areas, does the CAISO as market operator determine that, or do the EDAM BAs, CAISO as an EDAM BA or the other EDAM BAs determine what parameter is appropriate for their area? And I guess the same question goes here for the regional uncertainty. Is that something that CAISO as a market operator would determine would be appropriate within the CAISO BA and or other EDAM BAs, or is it the CAISO as a BA or the other EDAM BAs determining that they need to split how solar is assessed for uncertainty in the eastern versus western part of their system? So it loops back a little bit to some of the discussion that PG&E had on the call on Wednesday, but then trying to make that relevant here for kind of what determination is being made by whom, and if there's a difference in the different BAs.
Thanks, Dan. So a couple questions layered in there. So if I didn't address all of them, don't let me move on. So the first is about I'll just go back to the previous slide because this is what the question was related to, but essentially whether or not the parameter would be applied equally to all BAs and across all hours. Now, I think that the question is answered differently between what the intention is and what is possible to do. I think it is possible, and George can jump in on this if he needs to correct me, but I would believe it to be possible to differentiate this parameter by hour or by BA. Now, whether or not that's the intention, I think the intention would not be to do that unless there was some specific need for that, such that I think the intention would be that the parameter that's applied would be a market-wide parameter applied to all entities and applied across all hours, unless there was some sort of discovery about, potentially, let's say, for example, I could imagine a scenario where 23 of the 24 hours of the day, you may not need to mess with this parameter at all, but maybe it's found to be desirable that an hour ending 18, you can get better market results by moving this parameter down in that specific hour. I imagine that sort of thing to be possible. But George, can you confirm or correct me if that's not necessarily the intention here?
Of course, we haven't completed the design for this particular parameter since it's entering the proposal stage at this point in time. Now, it is possible to have a time variable Again, it's a static parameter. Once you tune it, it's good for a while until there is a reevaluation on it. It's not something that will change day in, day out. But yeah, it could have a 24-hour profile. Now, could it be done at the BAA level? Well, of course it could, but yeah, as you mentioned, that wouldn't be appropriate since you want to have all BAAs to be at an equal footing here, and you don't want to have deliverability of the balanced reserve product to be viewed differently depending on which BAA it's procured, particularly because it may be procured to serve uncertainty in another BAA. So it has to be a global parameter, but whether it's going to be for the same parameter for the entire 24-hour set of time periods in a day ahead, or it could change by hour. That, I guess that's a detail that I believe we can go down this path if we have, some justification of why it should be that way.
Yeah, I think in summary, I think that's essentially what I was saying, is that I don't think the intention would be necessarily to do that, but the ability to do that, I think it's possible. Now on this slide, I think my understanding is that the question being, who decides, is sort of a theme in the first three. For this one, I would see this to be, I would imagine that this would have a little more, and again, these processes have not been developed, and this is just me thinking out loud, but I would imagine the process would be a little more in the hands of the EDM entity relative to the others, in the sense that the EDM entities are probably best positioned to identify characteristics of their own BA, which might lend themselves best to sort of a separation in regions. So for example, there's few BAs that have resources or loads across several states with wildly different climate zones. And it seems quite possible that the EDM BA would suggest to the CAISO, if we were to go down a regional uncertainty layer, the EDM BA might be the one to say, here are the layers that we think are most appropriate for doing that. So again, the process is sort of to be determined, but I would think it would be, the EDM entity would be heavily involved in this decision. What sort of layers or zones to create in that layer of uncertainty. Dan, did I miss any questions, or would you like to follow up on any of that?
I think that covered through everything. I know it is pretty complex stuff and a lot of words to get out there when we're trying to shorthand the different roles that are being played by different entities, but I think that added a bit of clarification. So thanks for running through it.
All right, we have one more question in queue from Stuart Kelly.
Thank you. This is Stuart Kelly representing LA. I really welcome this tweak here, and I think this particularly helps LA DWP. One thing that I would ask though is that we have an increased focus on metrics when it comes to load forecasting. We traditionally look at the MAPE. I think given IR, there's an increased importance on looking at the actual variation day ahead in real time, because that's what we're procuring for, that uncertainty. So I would ask that the CAISO have more of a focus on that. That's been less of a focus, certainly from an EIM participation standpoint, but that becomes increasingly important here. So I would just ask for that particular metric, and maybe over time we can look at ISO being somewhat, having some goals around, performance in that area, because that would lessen the amount of IR and would lessen the autocorrelation and persistence that we would see. But again, I welcome this tweak. Thank you.
Yeah, thank you, Stuart. Yep, so we'll pass that feedback on to our forecasting team to keep in mind, moving towards implementing and monitoring the performance of DAME. If there's additional metrics that need to be included in order to do that performance appropriately, they'll be the ones to decide. Okay, let's move on to the next slide, slide 13. So we have some changes here to the imbalance reserve demand curve to discuss. I'm actually going to discuss these in two separate buckets. I wish I would have put this in two different slides, but I didn't, but bear with me. So there's sort of an overall change that applies across all EDM BAs, which is that stakeholders had voiced rather strongly that the imbalance reserve demand curve values as demonstrated or the idea of mimicking the FRP demand curve style for imbalance reserve might result in demand curve prices that are seen as being too high relative to the value of the demand curve. So we had quite a bit of discussion about this at the MFC meeting. And so the ISO is, you know, in order to accommodate those stakeholder concerns, essentially is saying that the ISO will no longer cap the demand curve value at $1,000, but instead will cap the demand curve value at $247, which is the same penalty price cap as implemented for flexible ramping product. So in essence, what this means is that the imbalance reserve demand curve and the flexible ramping product demand curve would be exactly the same functionality with exactly the same cutoff. Of course, the steps and the values would potentially be different depending on the cost and procurement of those products, of course. But the actual implementation will be exactly the same. That being said, that applies to all BAs in the EDM. Now, for the ISO BA, there is a separate distinction here in which the ISO is going to apply a separate concept to the Cal ISO BAA than for the other EDM BAs, in which we were calling sort of a hybrid design, in which we would subject only 50% of the imbalance reserve requirement to this demand curve, while the other 50% will be subject to higher penalty prices or protected at a higher level than the demand curve allows for. So although this sort of thing didn't come up in the workshop discussions, it's been a concern that's been brought up since the workshop discussions that it may be desirable specifically for the ISO BA who has intertie bidding as a feature in the EDM market to allow the ISO as a BA to protect some portion of its imbalance reserve over clearing low priority self-scheduled exports in the IFM. So they're sort of seen as providing two benefits to this approach. One is that the exports that clear the IFM will have more certainty in terms of there's a greater likelihood that when an exporting BA receives those awards from the CAISO out of the CAISO, there's more certainty that those exports will be honored and protected in real time. And what that's getting at is that if the imbalance in today, what would happen if the ISO as a BA was in a position where it had to relax all of its imbalance reserves? It would essentially, low priority self-scheduled exports would be the next to cut. And if you get into a position in real time where the upward uncertainty materializes, but the ISO as a BA has no imbalance reserves to rely on, essentially those low priority exports becomes the thing that you cut in order to meet the upward demand. And so it's just not seen as a good thing to not provide exporters more certainty in terms of what can be maintained in real time because of this issue. It also mitigates concerns from just generally that the ISO as a BA would have reserves to meet its own net load uncertainty in favor of clearing LPT exports in the first place. And so that's why it's subjecting 50% of the reserve requirement to these higher penalty prices. Now, for the former portion, again, the ISO as a BA would have a demand curve in place that's the same as the other demand curves. It's capped at 247, with the exception as not only are you going to cap the price at 247, but you're actually going to cap the percentage requirement at 50%. So the demand curve itself would be built to relax the requirement up to 50% of the reserves. And then from there, you're jumping into this higher penalty price value. And again, the last bullet demonstrates that, again, EDAM BAs participating in EDAM will only use the imbalance reserve demand curve and won't use this hybrid portion. So there is a slide on the next slide is related to this topic, but not specific to the demand curve, in which I'm just going to flash the slide. There will be, in relationship to this concern, updates to the real-time curtailment for exports process and RUC. But I won't, I just want to highlight if folks had questions about that there is that slide coming up, but we'll pause here on slide 13 for questions or feedback. There is one question in the room. There's
Testing?
multiple questions from one entity in the room.
Hi, Steve Keen from Southern California Edison. Okay, this is something that we have a lot of concern with, and we're trying to understand. You say that the demand curve will be the same, but that's not really true, because the demand curve for the CAISO BAA, well, I don't know, I assume it starts somewhere lower, like probably not at zero, but close to zero. And then it goes up to 247 at that 50%, and then it jumps up to a penalty price. Do you know what that penalty price is? I mean, are we talking $1,000? Are we talking $1,500?
So more than likely, the penalty price value, at least for the pricing run value, which is the price that's relevant in terms of actual market pricing, would be $1,000. The scheduling run value is not as easily defined at this time, because when it's a tricky thing to get the parameters correct in relationship to each other, because the scheduling run penalty price is only relevant for determining hierarchical priority of schedules. And so it would need to be tested to define a scheduling run penalty price value that gives it the priority of over LPT exports, but under self-scheduled demand.
Okay, and then in the other BAAs, it would start as close to zero, and then at the purchase level of zero would hit 247, correct?
Yes.
Okay. I mean, one concern that I have is just, you said you're going to buy this kind of overall, but you have a different, with different demand curve in each BAA. I don't understand how that process works. How do you, if the price in the CAISO BAA can go up to, $1,000, but you can buy it everywhere, won't you just be buying it in other regions? I mean, how does it work when you have a different demand curve in each of the BAAs, unless you have a specific amount that you're buying in each BAA?
I have to process your question some more. Let's go to an extreme, and then maybe that'll help sort of get things moving. So one extreme could be that you're in a really tight day across the EDAM. The demand curve in other BAs there's such supply insufficiency and high prices for this capacity that the demand curve is going to relax the full value of, it's not going to procure demand imbalance reserves for the other BAs, but then some portion of the imbalance reserve requirement in the CAISO BA will be protected. So there could be instances where, at an extreme, the ISO is preserving 50% of its requirement, and all the other BAs are buying zero. Now, where that supply comes from, it can come from ISO resources or from the EDAM. So it could be EDAM resources selling transfers into the ISO that the ISO is procuring. But that's sort of an extreme way of thinking about what could happen under tight supply conditions. Yeah.
Let me ask.
Yeah.
Listening to you with that, it raises an even simpler question. When you say 50% of the imbalance reserve requirement, is there a separate imbalance reserve requirement for the CAISO that you're looking at, or is that 50% of the overall imbalance reserve for all of EDAM?
Yeah, it's a good clarification. So it's 50%. So every BA will have their own imbalance reserve up and down requirements. And when I'm talking about the imbalance reserve requirement, I'm speaking of 50% of the CAISO's imbalance reserve requirement. So if the CAISO's imbalance reserve requirement's 1,000 megawatts of up, essentially you're going to have 500 megawatts subject to the demand curve and 500 protected at the higher penalty price.
but you said something about that could come from within the CAISO or from within the, so you could have a situation where a resource could get two separate imbalance reserve awards. One where it's doing it for the CAISO and it's being awarded at the $1,000 penalty price, and another where it's being awarded whatever the demand is in its own balancing authority, and it could be getting, it wouldn't be getting any more than $247.
I think I don't think the market would make that split. I don't know if George, if you want.
Yes, he is.
Yeah, George. Okay, George, go ahead.
Yes, thank you, James. This is George Angelevis with the ISO. So yeah, there is a single imbalance reserve product so far, right, in the design, and a resource could have a single imbalance reserve up award and then a single imbalance reserve down award. Now, this award can be used to serve the uncertainty requirement of the BA where the resource belongs to, or it could also be used to feed an imbalance reserve transfer that could meet the uncertainty requirement in another BAA. Now, the demand curve for the imbalance reserve product is really a property of the BAA because it's driven by the probabilistic cost of not meeting the uncertainty beyond a certain level for that BAA. So it's really depending on the uncertainty characteristics for that BAA. So we will develop the demand curve for its BAA, and then also you have the effect of co-optimizing the meeting the uncertainty from all resources across the market footprint that they have imbalance reserve bids. What this proposal does is for the ISO specifically, and we haven't heard from other EDAM entities where this would be useful for their case too. But just for the ISO, this proposal at this point says that the innermost segments of the demand curve, instead of leaving them at the probabilistic avoidance cost as it's calculated in the proposal, in the final proposal now, which the innermost segment could be anywhere between $400 and $600 if it's not capped by 247. Well, that will elevate it to $1,000, as James said, essentially making sure that at least that portion of the uncertainty requirement is met, irrespective of its cost, because otherwise, the effect of the demand, essentially the cost for procuring the product is higher than the probabilistic avoidance cost of not procuring it, then you will not procure the product. You will go with the risk in real time of not having all your uncertainty requirement procured. Now, this is a hybrid approach that actually secures a certain amount of the product, no matter what the cost for the procurement is. So it's not affected by the economic demand curve, which kicks in at the higher uncertainty requirement level. But its BAA can have its own demand curve, and it's still co-optimized within the entire market footprint. So on the face value, what the effect of this penalty procurement for a portion of the uncertainty for the ISO does, it actually gives a higher certainty for the ISO that will at least some of the imbalance reserve requirement in the ISO BAA will be met because it doesn't have an economic relaxation on it. And if there are capacity exports, imbalance reserve exports transfers out from the ISO to meet uncertainty requirements for other BAAs, if that is the outcome of the FM, that also has even a higher value in essence now, because you have the ability to have more export transfers, and some part of the uncertainty requirement is not on a demand curve.
Okay, I'm sorry, I'm still having trouble understanding this. What about a situation like this? Let's say where the CAISO runs out So its price goes up to the $1,000. Let's say that there's some remaining in the other areas. They will essentially be transferred to the CAISO and paid $1,000. So you'll have the CAISO getting, conceivably getting some of its imbalance reserves, but potentially the other EDAM entities not getting any.
No, Steve, it's still co-optimized, right? What happens is that most likely we will procure the product to at least for the $1,000 penalty segment of the uncertainty requirement, and we may even procure more depending on how the economics are. And if it is for the economic portion, if it is still less expensive to get imbalance reserve from another BAA as an imbalance reserve transfer import to fulfill the uncertainty requirements for the ISO BAA, this is still possible. You still have that, and you still have marginal prices for the imbalance reserve product, which are locational because of the deployment scenarios. So it's all co-optimized. It doesn't mean that the price for the imbalance reserve product will go to $1,000 unless there is not available capacity to even meet that $1,000 segment, and then you have to even relax that segment at $1,000 price. But I find this difficult to see in the day-ahead market.
Okay, I have to stop and think about this some, but thank you.
We do have two hands raised. Let's go ahead and go for J.K. Wong. Wait.
Oh, this is JK from PG&E. Can you hear me?
Yes.
Hi, James. I want to ask for the 50%, how do we determine that? And if that parameter is tunable?
So 50%, what that means is that if you take the ISO BA's requirement, and I would imagine would be post application of the diversity benefit. So if because that's the actual amount that would be procured within the IFM. So let's say that the ISO's requirement is post the diversity benefit is 1,000 megawatts. Then what this would say is that 500 it essentially would take 500 megawatts and apply that to the creation of the demand curve, where it would be capped at 500 megawatt quantity, and then subject the other 500 megawatts to higher protection.
Yeah, I understand that, but I guess my question is, why is the 50%, why it is not 40, 60, or other splits?
50 those are nice numbers, but the question is about tunability. So I could imagine that the ISO could, if it were desired by stakeholders, could implement this such that we'd have a way to tune the value of that's subject to the demand curve relative to the penalty price. George would have to weigh in on how difficult something like that might be, but it in concept seems desirable because in practice it may be it may not be necessary to protect such a high portion, or it could be the other way around, where in practice it may be found to be desirable to protect a higher quantity. And so if it were implemented to be tunable, that might be a good way to sort of make those adjustments as needed.
Okay, my follow-up question is this hybrid demand curves also going to be included in the day-ahead RSE in EDAM?
No, so the RSE will not include, so let me answer this by saying this way. The resource efficiency evaluation is a supply sufficiency test. And so it'd be our view is it'd be inappropriate to apply the demand curve to the resource efficiency evaluation, because the demand curve is applying economic relaxation to the product and not evaluating for supply sufficiency. And so the answer to the question is no, the demand curve would not be applied in the resource efficiency evaluation. all of the, I think the resource efficiency evaluation will assume some semblance of a high penalty factor such that it's only relaxing, and this is related to consequences of failure, right? Because that's determination of how much you fail the imbalance reserve requirement is sort of how the threshold of penalties is decided. So it's important that every megawatt is considered within the requirement, such that you're only failing the EDM resource efficiency evaluation if you truly don't have sufficient supply to meet the various demands in the test.
Okay, and so if the demand curve is not included, I would assume that in your day ahead RSE, that the imbalance reserves do have higher priority than the LPT export. Is that true for the full month?
Yes, but George is going to have to help me on how there's a nuance to how exports are considered in the resource efficiency evaluation. I'll let George explain it.
Yeah, thank you, James. So the low priority exports, obviously they're not considered as part of the RSC requirement because they are lower priority than demand. And the purpose of the resource efficiency evaluation is to meet the demand with the uncertainty. So high priority exports, of course, they're considered as part of the demand, but the low priority exports are not part of the RSC evaluation. And on the other hand, also for the ISO, economy imports, so imports that they don't have contracts, are also not considered for the RSC. And correctly, James pointed out that there are no economic relaxation of requirements in the resource efficiency evaluation because the whole test is to assess whether the available supply can meet all the requirements, not anything not only what the portion that makes economic sense. So there will be a high penalty for the imbalance reserve requirement in the RSC. I wanted to comment on your other question, JK, on the configurability of this parameter. And I want to mention also that, you know, the 50% of the imbalance reserve requirement, it's not very useful because it doesn't tell you anything about the probability of the uncertainty materializing at that level. And it, you know, the probability can be different every day and every hour of the day. So I don't find it very useful. I think a certain percentile of the imbalance reserve will be more useful. And in previous proposals on the DAME, when we were considering graduated penalty prices for the imbalance reserve product, there was some analysis that we did to find out what's the current rack adjustment that's performed by operations, what percentile comes to meeting uncertainty. And the analysis point out that it's anywhere between 70th and 75th percentile. So we can take this as a data point, driving the appropriate point where the appropriate percentile, we're going to make this imbalance reserve requirement at a penalty, so that at least you cover that percentile, whatever it is, maybe 50th or 60th or 70th. I think this is a more reasonable approach. We'll think about how we will do that, and of course we will communicate. Now, whether it's configurable or not, I see it as configurable. And the reason is that when we calculate the demand curve for every BAA for every hour, that is calculated from the raw historical data and the probabilities that we derive from that, without any consideration of capping it. And when it comes to the market application from the system that calculates this demand curves, it's your pure economic demand curve. And then the system in the market can process that and cap whatever portion you want, and that can be driven by a parameter, a configuration parameter. So I don't see any problem at all to have this configurable. Of course, you know, it's going to be quasi-static, not, you know, changing for this hour, the next hour, the next day. and we have to do some analysis and tuning to find a reasonable value and then stick with it until we need to reevaluate it and change it after reevaluation. Thank you.
Thank you, George. That's really helpful. Yeah, I guess what I was looking for is more scientific support and more careful examination of the splits rather than, more than it's a nice number, but I get a very satisfactory answer. Thank you so much.
We can go to Jonathan Glasgow. Please make sure to state your affiliation.
Hi, can you hear me?
Yes.
I'm with Puget Sound Energy, and I just wanted a little bit of a clarification. If a resource is providing imbalance reserve as a transfer, are they getting paid the price from the BAA in which it resides, or the BAA in which the transfer is going to?
So if it's the case where the it would be a really tight scenario to assume a case where all of the imbalance reserve were relaxed and all of the BAs but because the CAISO is on this portion of the curve, that prices, because you have to remember that you'd be cutting all the imbalance reserves across the EDAM and cutting all LPT exports out of the IFM before you'd even get to these penalty prices. But if that were the case, the $1,000 price would set the marginal cost of the imbalance reserve, such that if we were in that scenario, the $1,000 price is the relevant marginal price of the product, regardless of whether the supplier is within the CAISO BA or not. So I think the answer to your question is yes, that it's irrelevant where the supply is coming from in terms of what kind of demand curve is applied within that region, because the price will be applied to whatever is the highest value across the system in total.
So if there's an imbalance, if I'm doing a transfer, and let's say the transfer is not going to California, to the CAISO BAA, but it's going to a different BAA, but we're in that penalty number and we're at $1,000, even though it's not going to the California BAA, it's going to be $1,000 going to this, BAA 3.
So if we're in a situation where there's $1,000 penalty price for imbalance reserve, the only possibility is that the CAISO BA is the only one buying imbalance reserves in the EDAM at that point, because at that price, all of the other BAs would have lowered their demand for imbalance reserves to zero. So what I'm trying to say is that the CAISO would be the only BA procuring imbalance reserves at $1,000 price, and it would be irrelevant where those reserves are being supplied from. So let's say if you're you have a resource in your BA that is even though your BA may have a $247 cutoff and your BA has relaxed all of its demand for imbalance reserves, as long as the CAISO is demanding some at the $1,000 price and your resources are chosen to supply it, your resources would get the $1,000 price, and it wouldn't cut off that 247 even if your BA is not buying any.
What happens if there, obviously if it's $1,000, the California BAA needs it, but what if another BAA also is sort of short and needs some imbalance reserve? What price are they going to be getting or paying or whatever?
Yeah, so for all other BAs, they're going to have this demand curve applied, which we can follow up to if we want to spend more time on how the demand curve is constructed. But essentially what it's going to look like is sort of a stepped curve that at each there'll be segments of the requirement. Let me try to put some numbers. So let's imagine there's a 100 megawatt imbalance reserve requirement subject to this demand curve in an EDAM BA. You could imagine that maybe there would be 10 steps of 10 megawatts, where at each step there would be an increasing price relative to saying that BA is no longer going to procure that quantity at that price. So let's say the first segment's $10. So then you might say, if the price of procuring 100 megawatts is more than $10, I'm going to relax my requirement to 90 megawatts. and then and so on and so forth at increasing prices until you get to the end of the curve, which would be capped at $247. So that's to say that if the marginal price of imbalance reserve for an EDM BA was in excess of $247, that BA won't buy any imbalance reserve. So they wouldn't find themselves in a situation where they're going to pay $1,000 for the imbalance reserve because the demand curve would cut them off at 247. Now to add on to that, of course, if it were found desirable for EDM BAs to avail themselves to a different demand curve structure, for example, if they wanted to implement this hybrid approach, I don't see why that's not possible. But that's the current way. Does somebody have a George wants to add on? Okay, George is going to add on.
Yeah, I just want to clarify that the price for the imbalance reserve product is the marginal price for the product at the specific location of the resource that has the award. And there is no direct link between an imbalance reserve transfer with a specific resource. It's like the portfolio of resources in a BAA that feed into, let's say, an export imbalance reserve up transfer. Now, in the scenario that we're considering here, having potentially $1,000 price at the California ISO BAA because you didn't have enough supply to meet even that portion of the uncertainty requirement, and whether this price is going to be seen in other BAAs, it really has to do with the available transfer capacity. Because obviously, any imbalance reserve bid anywhere in the market footprint will be dispatched to meet that $1,000 cost for the uncertainty requirement in the ISO if there is available transfer capacity. So in the scenario that we're talking about, not having sufficient imbalance reserve everywhere in the market footprint to at least meet the $1,000 uncertainty requirement for the ISO, it's a very unlikely scenario. What is likely is that trying to do that, you may hit the transfer capability limit, and then there is price isolation between the ISO and the other BAAs in ADAM because your import transfer to the ISO is at the scheduling limit, so that provides isolation. So you may have a scenario where through the whatever available imports for imbalance reserve that you could get until you hit the scheduling limit of the import transfer, and whatever available imbalance reserve bids you have in the ISO, you can still meet the $1,000 requirement. Again, an unlikely scenario, but in that scenario, you will have a $1,000 price for the imbalance reserve product in the California ISO BAA, but you should not see that propagating to other BAAs because the transfer constraints provide price isolation.
So in a similar example, let's just say that I have a resource that can provide 200 megawatts of imbalance reserve, and I'm in BAA 1. BAA 2 requires 100 megawatts, and there's no transfer issues there. And CAISO BAA also needs 100 megawatts of imbalance reserve, and there's no transfer issues between 1 to 2 or 1 to CAISO. And I have the 200, I could support both. Is my 200 megawatts of imbalance reserve going to get paid $1,000 for all 200, or am I only going to get the $1,000 for the 100 that goes to California and the 247 to the BAA2?
So there's a single price. You're not getting different prices for different.
Okay, so California set, so the California BAA would set the price at 1,000, and in this situation, I send them 100 megawatts of imbalance reserve, and to BAA2, I would also send 100 megawatts, and it would be at a price of $1,000, even though that's more than what their demand curve is capped at.
I need to caveat that this is the extremely unlikely scenario that you don't have binding transfers to provide price isolation, and all the available imbalance reserve bids in the entire market footprint, including the ISO, cannot meet the whatever percentile for the uncertainty requirement of the ISO is set at $1,000. That is a highly unlikely scenario to happen. You can see that, right?
Yeah, I'm just trying to make an example.
Possible.
Right.
It's theoretically possible. It can happen. Yeah, theoretically it can happen. Yes.
Yeah, I was just trying to get to the point that it's, there is one price. It would set it for everybody, even though other BAAs would be capped at 247. But if the CAISO gets to 1,000, everybody's getting paid 1,000 for all their IR imbalance reserve.
Again, I just want to caution. It's a theoretical outcome. It is, I consider it impractical, right? Because let's say it's 2,000 megawatts of requirements that is under $1,000 penalty for the ISO. That will only happen if you have less than 2,000 megawatts of imbalance reserve bids in the entire market footprint and sufficient transmission capacity both for energy and imbalance reserve so that the ISO can pull everything in and still don't have enough to meet the 2,000 megawatt of requirement. So under that theoretically and very unlikely scenario, yes, it will happen to have $1,000 marginal price for the imbalance reserve product. Yes.
All right. Thank you.
All right, let's go to Callie Wells.
Hi, it's Callie Wells with WPTF. Can you hear me okay?
Yes, we can.
Okay, great. Thanks. I had a weird notification about muting and unmuting, so just wanted to make sure. So I actually just have a clarifying question, and I apologize if I missed this detail earlier on in the conversation. But setting aside the CAISO BA demand curve, you said all the other EDAM BAs will have the same demand curve. Will the megawatt and price step points along those demand curves also be the same? I know they're all going to be capped at 247, but will they have different prices and megawatt steps?
So the demand curve for each BA is different, Kelly, because it's driven by the historical data of uncertainty for each BAA, right? So each BAA has, its own uncertainty features and characteristics. So when we calculate the demand curve for each BAA, that will look different for each BAA, not only the segments, but also the prices. If the uncertainty characteristics are, roughly similar in terms of the historical data, then you may have curves that look similar. But in general, there will be different curves for each BAA.
Okay, that's what I thought, but I just wanted to confirm. So actually each BA they'll all be subject to demand curves, but their specific demand curve will all differ.
Yeah, that's
right. So your quantities and prices of those segments, they will generally be different for each BA.
Okay, just wanted to confirm. Thanks.
Dean from Edison again. I just want to confirm something. When you're allocating the costs of IRP out, all right, we haven't talked about that yet, but are those being allocated out on a BAA basis or on an overall EDAM basis?
So the allocation of costs for imbalance reserve will account for transfers. Is James Lynn on the panel? Does he want to clarify how this would work? Go ahead, James.
All right, so make sure I was unmuted. So it's going to account for transfers to start with. And then once we account for the transfers, each BAA will have their own allocation of that BAA's cost. So if I have one BAA that is providing imbalance reserve to another BAA, we're going to settle that imbalance reserve transfer quantity, and that then shifts the cost into a BA by BA basis. And then once it's in the BAA, we have for the ISO, there's a two-tier allocation methodology that is going to be applied. For EDAM, this allocation is directly to the EDAM entity for the EDAM entity to allocate per the route.
Okay, then let's assume we get into a situation where it's tight across the whole West. Then basically the CAISO, by setting a $1,000 penalty, is going to be providing imbalance reserves for the entire EDAM. And, you know, to the extent that they don't get them from CAISO entities, but they get them from other BAAs, they're going to be, you know, yeah, they'll be paid the $1,000. They'll be assigned to the CAISO for allocation. But they're actually, you know, since they're sitting in another BAA, even though that BAA didn't buy any EIRP because it, you know, that it went above their, you know, that there wasn't any available, it went to the CAISO instead of there. They're getting benefit from it, but they're not paying for it. Because it's, you know, yes, it's providing the $1,000 minimum amount to the you know, that 50% in the CAISO BAA. CAISO's paying $1,000 for it, but because the actual resource is located in another BAA, it's hard to say that the benefit is all going to the CAISO. That other BAA is obviously going to get some of the benefit of that IRP because it's, you know, if it's needed there, it will, you know, since it's located in that BA, it'll be used for that. But yet, as I understand it, they're not going to be paying for it.
James, do you have a comment to the settlement part of the question?
Yeah, from a cost causation purposes, if the imbalance reserve was procured from a resource in another BA to meet the ISO's imbalance reserve needs, then cost causation says that it's the ISO BAA that should pay for that imbalance reserve cost. Now, from an overall footprint, if we have a diversity benefit, yes, there should be a diversity benefit that should reduce the overall procurement. And in real time, when they bid in, the overall WEIM BA will benefit from the increased bid. But remember that the whole cost causation says that resource was procured to meet the ISO's imbalance reserve needs, and therefore it actually belongs within the ISO BAA for allocation purposes.
No, yeah, I understand that. I understand how it's working. But what I'm saying is, if we're in a situation where things are really tight and across the whole footprint, we're down to below the 50% for the ISO. So, you know, the ISO is procuring some in its, because of the 50% penalty price, the penalty price for that lower 50%, it will be sucking in whatever it can from the rest of the grid, and they will be getting nothing. You know, if the prices were if the demand curves were the same in those two, or if they had the same penalty price, then yeah, those resources would be preserved in each of the balancing authorities, and each balancing authority would be paying for what was locally there. But in this case, it's, you know, the CAISO, by virtue of the fact that the CAISO has the 50%, has a penalty price of $1,000 for 50% of its IRP demand, whereas none of the other ones do. It's possible that the CAISO could be providing IRP for the whole grid, the small amount that's available.
I think there's also a nuance here. Well, yeah, James, let me. I think there's also a nuance here about if you're procuring imbalance reserve from a resource outside of the CAISO that's transferred into the CAISO, that transfer quantity is protected in some way in real time, such that if all of a sudden the BA with which the supply resides has upward uncertainty, that that portion of the supply is dedicated to the CAISO for transfers. Is that part of that's part of the question, right?
Yeah, but I mean, it would get realized in real time, right?
Right.
So in real time, if there's imbalance that occurs in the other BAA, are you saying that resource they won't use that resource to match the imbalance that occurs in the other BAA, that it would be saved for the CAISO?
So it may not be the same resource, but I think that the quantity is the transfer quantity is protected. James, yeah, go ahead.
Hold on. No, the imbalance reserve transfer quantity isn't per se protected. What it is that we have to bid in, and the overall requirements is protected. So if it is to resolve the ISO, real-time requirements, yes, there is an additional requirement protection in there, because we are seeing that this capacity was being used to send energy, or potentially energy, from one BA to another. And the market's going to optimize that overall capacity and determine where is the optimal use of that energy is. Now, we also have an imbalance settlement of flexible ramps from that resource that was secured for imbalance reserve, that will have different cost shifting based upon that procurement of that resource for flexible ramp. So my question to you, Steve, though, is your concern on the cost causation principle of this, that if the imbalance reserve was secured in another BAA, that the BAA which it was secured for should be paying for it? Or is it the fact of the pricing caps might be driving that procurement mechanism?
I think it's more of the second, and it's the difference in the demand curves between the CAISO and the other BAAs. I can see has the potential that the CAISO may be the only getting IRP. If there's really a shortage out there, all of it, at least as much as could come to the CAISO, would be coming to the CAISO, and the cost would be allocated to the CAISO at the $1,000 price. But to the extent that that you can share IRP across the grid, the other BAAs may be benefiting from that. If what happens when we get to real time is that the imbalance doesn't necessarily occur in the CAISO, but it does in some of the BAAs, those resources will be useful for meeting the imbalance in the other BAAs, even though they didn't pay for it. And I see a problem. This basically what I think I'm seeing a problem with is the fact that the demand curves are different in the different BAAs, and that can lead to, I think that can lead to some strange results.
Steve, I don't understand why you say that the resource that is used for an uncertainty that materializes in its own BAA is not getting paid for that. I don't understand all this theory here. What IDAM does, it considers all the imbalance reserve bids everywhere in the market footprint, including the demand curve. The demand curve appears like a supply bid for relaxing the requirement for that BAA, but it competes with all the other bids. So you have all these bids that compete economically to meet the requirements of all BAAs in the market footprint. So it's all a collective co-optimization, right? So the IDAM does not prioritize the use of an imbalance reserve bid in a BAA for meeting the requirements in that BAA and then looking outside. It's just doing it globally for the entire market footprint, and its resources paid the marginal price at its location for the product. It's not much different than energy, right? So I'm trying to demystify these concepts that now we have this $1,000 requirement that has to be met, whereas everything else is met economically. And you may have the possibility that maybe it cannot be met, that portion, either because there's not available capacity in the ISO to meet it and the transfers are locked in, they're at the scheduling limit, so you cannot get external capacity to feed that. And then you have $1,000 price for the imbalance reserve product ISO, or the other scenario that we looked at earlier, that maybe all the available capacity in the market footprint is not sufficient to meet that requirement, and then again you have $1,000 price for the product throughout the market footprint. Now, when you go into real time, all of these imbalance reserve awards, they will come in with an energy bid, and the real time, the EIM will dispatch them economically wherever the uncertainty materializes, either in the same BAA or in another BAA. It will be dispatched economically to meet it. So I can't follow your reasoning here, and maybe there's something that I'm missing that you're trying to drive, that maybe from a cost causation principle, we have some problem, because I don't see it.
Let me see if I can come up with an example. Let's say the CAISO's total demand is 1,000 megawatts, and the other BAAs are, there's a couple other BAAs that have 100 megawatts of demand. Let's say it's really tight across the whole West, really hot, whatever, so that the amount that's actually available across the entire West is only 400 megawatts. Some of that may be in the CAISO BAA, some of it may be in the other BAAs, but essentially because the other BAAs, when the price gets above 247, they're buying zero. They're not buying any. The CAISO, because it has that demand, it has the penalty price that kicks in at half of its demand, so at 500 megawatts, it's going to buy all 400 that's available in the whole footprint at $1,000. It's all going to be assigned to the CAISO. So my understanding from what James was saying is those costs will all be allocated within the CAISO. So the CAISO will pay for all of that was available at the $1,000 price. However, since some of those resources may not be in the CAISO BAA, they may be located in the other BAAs. When you get to real time, they're going to be able to provide this, an imbalance energy. And I don't think this is what I wasn't sure of, but it seems like if there's a need for them in those other BAAs, they will respond. So the other BAAs are getting some benefit of the imbalance reserves without having to pay for it.
Not true, Steve. Yeah, I think you're mixing availability costs and payments with real-time imbalance energy costs. All right. So in your scenario, yes, the ISO load, essentially, depending on the tiers that we allocate the cost for imbalance reserve, the ISO BAA determinants for the cost allocation will cover the cost for the imbalance reserve procurement, both for internal and external resources. All right, is what you said. We're buying all the imbalance reserves, so we pay for it. These resources are paid their marginal cost. In this case, maybe it's $1,000. Okay, but that's the availability. All right, to be available in real time, not for the ISO per se, but for uncertainty that may materialize anywhere in the market footprint. So when that uncertainty materializes in real time, and it could materialize in the ISO, it could materialize in their own BA or in another BA, it doesn't really matter. We'll do an optimal dispatch, and that's the energy cost associated with that. You cannot say that, we paid for availability of this to meet our own requirements, and in real time, it's used economically maybe to meet uncertainty that materializes in another BAA. So you realize a benefit, and we paid for that benefit. No, we paid for the availability, and the availability is there. If we have the uncertainty, that resource will be dispatched to meet our own uncertainty. So the availability cost is prudent, is there, and because the availability is there. It's not that, they're getting a benefit that, they're not getting, we're paying for it. I think it's a wrong way to see it.
But if we're getting that benefit, then, assuming we get to real time and imbalance materializes, and let's say it doesn't materialize in the ISO, but it materializes in the other BAs, then it should be the case that that availability, those resources that we've paid for the availability for, should not be able to be used to meet the imbalance that occurs in the other entities. It should be reserved for us in case we need it at a later point in the hour.
That's not how IDEM works. However, when we were discussing the confidence in transfers, we did point out that imbalance reserve transfers, the same as energy transfers, they're firm in real time, which means that if uncertainty materializes both in the ISO and in the native BAA where the imbalance reserve was procured, that transfer of the imbalance reserve to the ISO is protected under that construct, meaning that if the external BAA, if the other BAA has also uncertainty materialized, and to the point that you can't meet both your own requirements and the ISO requirement of the transfer, the ISO transfer has the same scheduling priority as your own load. So we have this constraint that will prevent the cut of the transfer before a power balance constraint violation in the external BA. So your transfer is still firm. So you're still going to have dibs, if I can put it that way, on your uncertainty met through a transfer by imbalance reserve in another BAA.
The transfer is there, but what I'm saying is, basically, we don't have dibs because it's the same priority as the local load. So if the material, if the imbalance materializes in both entities, they'll share that. But it was the CAISO that paid for the availability for it. I know, I'm sorry, I don't think we're going to resolve this right now. And I need to think about this a little more too. And which I'll do. Thanks.
So there's two more questions over the phone. There's one from Stuart Kelly and then Roger Avalos.
Yes, thank you. I would just ask, this is somewhat of a kind of late design modification. I get where it's going. Just given the discussion, I think stakeholders would benefit from some examples pertaining to edge cases. I think there's definitely things to call, and I recognize where Steve's coming from, but there's potentially some other elements to consider. If you take a scenario where CAISO is the only one that's procured IBR because the price is above 247, so other EDAM entities don't have any imbalance reserve, and then in this edge case scenario, that as you move, ETs are actually, as you move to real time, and then if you take the E that's providing that IBR, let's say it lost a unit since day ahead and it's really tight system conditions and can't replace that, it's left to take alternatives. One of those alternative actions may be to utilize the export constraint and close it. So that IBR that was going to be provided to California is no longer provided to California, even though it's set aside for California. And so what happens, and demands, the uncertainty is fully realized and demand is above supply. You've closed the export constraint. You would ordinarily expect that resource to be sitting and not providing any capacity, but let's say it's on AGC, it ultimately provides that capacity. So you don't quite get the intended outcome because of all the interplay of the design elements that we've brought to the DAME process. So given this is late changing, given the level of discussion here, I think we should probably lay out, some edge case scenarios so that folks understand that they're not getting, have not procured any, could still be providing, and everybody through the transmission priority, what it PT, and you should understand PT should get cut, but aware of some of this anomalous outcomes that you intuitively expect. So I just ask for some scenarios be followed up post this stakeholder meeting, given the discussion we're having.
Okay, let's take Roger's question.
Roger, you've been sent a prompt to unmute yourself.
I think Roger put his hand down so we can move along. Did you? Can we go and take the phone line question?
Hi, thanks. This is Kathleen Colbert from Vistra. Can you hear me?
Yes.
Sorry, our
Oh,
mics
great.
have
Okay,
a
thank you
delay,
for
so
confirming.
our mics have a delay. That's why it takes us so long to respond. Sorry about that.
That's all right. I just wanted to make sure. Okay, great. Thank you. This is a valuable conversation, so I thanks to the CAISO for allowing space for this. I want to share that I think that part of the trouble with thinking through it in this discussion is that the example that you laid out kind of up front, James, was a bit simplistic and misleading, because there was something you said that was so important that I think may have gotten lost just in all of the, follow-up. And what you said that was so important is that, this proposal would apply to the BAA requirement that includes a diversity credit inside that requirement. So this would be being applied after or post credit, I think is how you framed it, which was critical to clarify. So I wanted to highlight that. What's so important about that is that your current proposal does not include a minimum requirement, nor does it include a proposal to change the diversity credit from a system credit to a more of a regional credit that would kind of work as a proxy to fix the problems if you don't have a minimum requirement. So, if we can incorporate the concept of the diversity credit into this example, I'll put forward my own reductionist version of this scenario, where, as we all know, the CAISO's BAA comprises a very large share of the it's a large driver of the uncertainty needs across the system, but it also receives a very large credit because of the import and export capability around the CAISO. And so in practice, what I believe is likely to happen, not just in edge cases, but on a regular basis, is that the diversity credit, as we saw back before there was a minimum requirement, resulted in the CAISO's BA requirement being effectively zero. So a $1,000 segment on a curve for 50% of zero will be zero. And the economic clearing for the other 50% of zero, I will expect to be zero. So I actually expect there to be very little requirement, if any, from the CAISO BAA. And for external to CAISO, so non-CAISO EDAM BAAs, they will also include a credit. So let's say that they're making up the majority share of what is required for this uncertainty product. The other really important part of this scenario that was not captured is that non-CAISO EDM BAA generators or resources will not have a must offer obligation. So if the product doesn't show much value, then I would expect there not to be an incentive to offer. So in my reductionist example, I will assume no offers for imbalanced reserves from any resources that do not have a MU, which is essentially the flexible RA resources inside California, will have a must offer and will be subject to mitigation. So in my scenario, I think it is more likely that there will be some requirement to provide uncertainty to non-CAISO areas that will be supplied by flexible RA resources. And I believe that the CAISO operators will see this as they did in the past, see concerns with FRP not addressing these issues. And what will likely happen is they will bias the load forecast that's used in the day-ahead market to fix these problems. And that will also be impacting the net export constraint. So the net export constraint will further limit the amount of exports that can be used to support transfers out of the CAISO area, because I am sure the operators will see that there is this reliability issue and they will address it through their biasing. That is my expectation of the outcome of your current proposal. And like I said, I'm confident the operators will manage around this reliability issue with the tools they have. So I'm not saying there's a reliability concern. I just think the scenarios that we've been discussing are very unlikely.
Thanks. Yep. Okay, thanks everybody for that discussion. Appreciate the feedback. I'm going to move on to slide 14. So this is a related topic to the previous topic. It's not demand curve related, but it's related to this concept of how LPT exports and other things are determined or shown as at risk of curtailment out of the RUC process. So, you know, today the RUC process essentially provides essentially a warning to LPT exports that don't otherwise pass the RUC process that they're at risk of curtailment in real time. In fact, the exports that don't clear the RUC process have a lower scheduling priority than exports that do pass the RUC process in real time. And so there have been some day-ahead market enhancements introduces updates to the RUC market formulation that requires changes to the process for indicating that exports are at risk of curtailment in real time. So we'll try to go through this step by step here. First of all, to say that economic exports can submit reliability capacity up bids in the market. And if awarded reliability capacity up, that reliability capacity up award will be paid at the relevant marginal reliability capacity up price. So that's already a feature of the DAME proposal that economic exports can do that. However, if economic exports that don't bid for reliability capacity, and of course LPT exports can't bid for reliability capacity because it requires an associated energy bid, those economic exports that don't bid and LPT exports still need to be considered in the RUC scheduling run to identify if they're at risk of curtailment. So essentially what RUC will do is they'll take those exports that are not participating in reliability capacity and considering them in RUC at the penalty price value that maintains their merit order of their energy bids in the IFM, which is essentially to say that economic bids would be cut in merit order of their economic offers, or sorry, I shouldn't use the word cut. Economic exports would be prioritized lower than the lower they bid and below LPT exports in the RUC process. So essentially what this would do is that if there was insufficient capacity to meet the demand plus these exports and LPT exports, that the reliability capacity process can award what we'll call proxy awards, reliability capacity awards to these types of exports, which essentially is similar as saying, it's a similar process as today where LPT exports and other exports can get IFM schedules that are then reduced in the RUC process. That's an indication that to those exporters that those exports might not be available in real time based on the current conditions. So essentially what that means is that if one of these exports were to get a reliability capacity up award, whether or not it's from an actual bid or through these proxy awards, that the export scheduling coordinator is then obligated in real time to submit economic bids for that RCU capacity. So if you're an LPT exporter that gets through this process, gets a reliability capacity up bid, essentially you go into real time and you are required to bid in an economic value for that portion of the capacity, which is the same as other must offer obligations for reliability capacity awards. Now you can submit this reliability up capacity at with a $1,000 energy price in real time, which, you know, functionally, if we're going to be cutting those $1,000 bids, we're at the top of the supply stack anyway. But again, it's the old process of how exports get reduced in the RUC is not maintained with the new market formulation, and so this type of process is necessary to keep that. Now, one other thing I mentioned I haven't mentioned yet is that these proxy awards are necessary to highlight exports that are at risk of curtailment in real time, and these awards will not be paid the marginal reliability capacity up price because they're it's done as a necessity for this process. So because they're not actually bidding for the product, they're just included within the stack of RUC reliability capacity up to be considered within RUC. They are not paid the marginal reliability capacity up price. I'll stop there to see if there's any questions or feedback on this topic.
So we do have a question in queue. Jonathan Glasgow, go ahead and please unmute yourself.
Thank you. Can you hear me?
Yes.
Great, thanks. Again, Jonathan Glasgow with Puget Sound Energy. And thanks for that explanation. That definitely helped me out a little bit, but just to make sure that I get this right, these economic exports, whether they bid RCU or not, and these LPT exports are cleared transactions in the IFM, correct?
So,
because the RUC is run after the IFM, right? So these are already cleared and awarded to the market participants.
The way I understand is they can be cleared and awarded. I think that the process would include reliability. I think the process may include, well, I don't know, George, do you have, or maybe George can help me out with that one. Whether it's dependent, this process is dependent on these exports clearing the IFM for them to be included in RUC. Okay.
Right. So
yeah,
so
I mean, if they don't clear, they're not there, right?
Right. So these are cleared in the day ahead market in the IFM. So thus they are obligations that CAISO has to the participants that it was awarded to. So basically, if you're saying that in the RUC, if there isn't enough, if they can't procure enough energy in the RUC, that you'll cut these obligations that you have from the day ahead market, correct?
Well, that's not exactly what we're saying. What we're saying is that you have an energy schedule. You know, your economic export or your LPT export clear the IFM. So that's, you have an energy schedule. You have a settlement for that energy schedule. That's your day ahead energy settlement.
Right, and that's an obligation for the ISO.
Yes, and it is an obligation in RUC as well. We want to meet.
Right.
When RUC substitutes virtual bids and any load under scheduling with reliability capacity up, let's say, the RUC will do everything possible within the reliability capacity bids that have been bid in the system, and will commit potentially additional resources to meet the demand, right? Including whatever economic exports and LPT exports have cleared the IFM.
Right.
What James is saying is that in the scenario where you don't have sufficient available capacity, to procure reliability capacity up to meet that target, then similar to today's rack or LPT exports and economic exports, they have lower priority than demand. They would be cut in rack. Here, the alternative is we give out an indication that those economic exports, and perhaps if we reach that high in the stack LPT exports, they will have a notification that there is a certain amount of reliability capacity up that is counted towards them, which means that they have the obligation to either participate economically in real time, submit a bid, and have the market resolve economically the curtailment, right? Because they have lower priority than demand. So they will have to be curtailed. But if they submit an economic bid for what was the proxy reliability capacity up award that came out from RAC, then that will be resolved economically through the market. And if that bid, you know, if it is $999 or $1,000, then you have a similar effect than cutting the LPT export, right? So what we're trying to do is we're trying to provide a similar functionality that exists today in RAC that gives a notification from the day ahead that your export is in risk of curtailment in real time. That doesn't mean that it will happen, right? Because it depends on the real-time conditions. But you do get that notification and that advance warning today from RAC, and we wanted to give you the same ability here in DAME, that RAC will actually assign or publish for you a reliability capacity up proxy award saying, you know, this is the amount of the export that from the day-ahead market cannot be supported, so it's potentially up for a curtailment in real time, right? That's
Right.
the intent
So
of the.
I've, you know, understood. I do have two concerns with this, and I think it's more fundamental, and realizing that it's already sort of in the market as it is, but the fact that you're procuring, you're clearing the market, and you have that obligation, and now even through RUC, you're saying we can't fix that obligation. Well, that's, you know, that's sort of a reliability. You gotta fix that, and if you can't fix it, then that's, you know, sort of like, you know, in my opinion, as a you know, I'm NERC certified, so I'm saying if you can't fix it in the day ahead, that is an issue to me, because you should be able to fix that with RUC without cutting schedules. Because of my understanding is that if you're cutting exports, that's something that happens once an EA gets declared. You don't do that in the day ahead market. You don't cut schedules that you've already been obligated to supply because it cleared the market. That's just my opinion. But then additionally, are these LPTs and economic exports, they're paying the same price that everybody else is because it clears the market. So it's not like, so there is a chance that these are less firm products, but but you're paying for the same firmness as everybody else is. So it seems like that's really risky for people to be doing this. It's, like I said, it's more of a comment than a question, but it brings concern to me about that whole aspect of it. So thank you for listening to me.
Sure. I just want to point out, it's not a change in policy. This is what happens today with RAC. So we're just, you know, continuing that existing policy we're making. We're connecting the dots here. We're not changing the policy, right? Okay.
Right. I was just sort of commenting on the policy in general.
Okay, we'll move on to slide 15. So this issue also gained a lot of traction through the workshops and through the Market Surveillance Committee meeting that happened a few weeks ago, where stakeholders had expressed concern that the restriction of the imbalance reserve award to only the 15-minute ramp capable portion of the resource essentially was too restrictive relative to the real-time need for ramping And so the ISO is proposing in this latest document to expand the definition of the imbalanced reserve product to include a 30-minute ramp capable portion of the resource. So essentially, as I mentioned, the stakeholder concerns pointing out that the real-time net load uncertainty often arises with longer lead times and is correlated between hours, which is another way of saying that oftentimes, at least not the full quantity of the imbalance reserve requirement materializes in such a short interval that uncertainties can be anticipated reasonably far in advance, where you don't necessarily need the same amount of ramping speed as you would with very quick and sudden changes in load. And so therefore, the 15-minute requirement may be too restrictive with this in mind. And ultimately, it comes down to costs, right? That by using only 15-minute ramp capable portion of the resource, you essentially limit the quantity that any individual resource can supply, even if they have plenty of upward or downward headroom available or on offer. You only can consider the 15-minute portion of it. And so that requires essentially more resources to be more resources to have in balance reserve awards, potentially leading to additional commitments of resources that are 15-minute dispatchable in excess of what you actually need. So, so the ISO has decided to extend the ramp capable portion to the 30-minute portion. Now, to be clear, it does not. This proposal does not change the resources that are eligible to provide the product. You still need to be 15-minute dispatchable, which means that your energy schedules can change on a 15-minute basis, and that fact doesn't change. Nor does it change the fact that resources can provide offline reserves as long as their can start up in 15 minutes or less. So it does not extend the startup time requirement for an offline reserve award. It just takes a longer quantity or a larger quantity of the available reserves in consideration for the awards. And I do want to also point out that there is a deviation settlement between the imbalance reserve product and the flexible ramp product. At this time, there's no anticipated change to the deviation settlement with FRP. Functionally, a smaller portion of the imbalance reserve award would be subject to deviation because it's only the five-minute ramp capable portion that's related there. So you might have a larger portion of the imbalance reserve award that's only a subject to the no pay if it's not available and not to the deviation settlement. So I can let James Lynn weigh in on that if there are some questions on that, but hopefully that makes sense, and I'll pause for feedback and questions.
Before we go to Joshua Arnold, James, did you want to add on something? Okay, so we do have 10 more minutes left for noon, so we'll go ahead and take Joshua Arnold for PG&E question. Hopefully that's correct. Joshua, go ahead.
Yeah, good morning. Josh Arnold, PG&E. Can you hear me, guys?
Yes.
Great. James, I am still very concerned about the lack of changes in the settlement process. We've been commenting, PG&E has been commenting for several years now about perceived inaccuracies and incorrect aspects of the settlement. Simple things like where a resource that does not provide the bids it is mandated to do by being awarded IBR does not see a full no-pay process. It still retains, 5-minute payment for things like forecasted movement, which are solely a function of the real-time market. I really want to push again, as I did in the last MSC forum, that the settlements need to be re-examined. The changes to this proposal have been considerable since the settlement proposal was first introduced. I think we need to take this back to the drawing board and really look at what the settlement should be, given all the changes that have occurred in this process. Thank you.
Thanks, Josh. And if I may ask, are your concerns specific to the settlement of the deviation settlement, or you have a wider view of this concern?
For me, the deviation settlement is, I think, the major cornerstone, but I think we need to take a step back and review the entire thing, just because the scope of the initiative has changed so considerably since the settlements were first introduced.
Thank you. Thanks, Josh.
Thank you.
Okay, so I'm going to try to get through another slide before we pause for pause for lunch. See how well we do. Oh, this might be a good place to pause because this topic actually has a few slides and is a little longer than the others. So this might be a good time to stop.
Okay, great. Thanks, James. So we will go ahead and take lunch right now, and let's be back around 12:50 so we can kind of start on time and wrap up for the next agenda items. But other than that, we'll see you all in 12:50 to begin our session. Thank you.
Okay, welcome back from lunch. So we will continue on with the material, leaving off on slide 16. Slide 16 begins, I think, a 4-slide series on congestion revenues. And at the end of I think it's 4 slides, I will pause for comments. These items are a little bit more detail intensive, so there's a few more slides to make these points. So as was discussed in the workshop material a few weeks ago, the ISO had been brainstorming a mechanism to collect congestion revenues on imbalance reserve flows in the deployment scenarios, is essentially in response to stakeholder concern that without a mechanism to collect congestion rent on these flows, the ISO would be shifting costs away from entities who are entitled to those congestion revenues and not considering the full cost of using the transmission system in the procurement of the product. And in the workshop discussion, there was an example that was shown where essentially what can occur is that because of the deployment scenarios introduce competition for energy flows and imbalance reserve flows, essentially to use transmission capacity. What could happen is that these imbalance reserve flows can actually displace what would otherwise have been energy congestion that would be collected through the energy settlement. And by essentially by no longer collecting that energy congestion revenue, if that's the only process by which you're collecting congestion revenue, you're essentially not collecting the full amount that's present on the system. So that caused the ISO to think about this mechanism, and it was presented to the MSC and in the stakeholder workshops. We'll get into a little bit more detail on those mechanics in these slides. Slide 17 demonstrates the proposed mechanism. So the first sub-bullet describes the process for imbalance reserve up, and the second sub-bullet describes the process for the down. They're just the reverse of each other. So I'll just focus on the upward scenario. Essentially, the ISO would determine the displaced congestion revenue from imbalance reserve upflows by this calculation, where you would sum up the product of the imbalance reserve upflow times the shift factor times the shadow price of the transmission constraint for all binding constraints in the upward deployment scenario. So first, that would be for specifically calculated for constraints that are binding in the upward deployment scenario. Of course, if there are no binding constraints in the deployment scenario, none of these take value, and there's no congestion revenue, displaced congestion revenue determination through this. So the ISO would do something similar for the downward product by calculating and summing the product of the imbalance reserve downflow times the shift factor times the shadow price of the transmission constraint for all the binding constraints in the downward deployment scenario. So it's important to talk about this method for getting at how much of the congestion revenue is displaced out of the energy scenario that would otherwise have been collected but is not because of the introduction of the deployment scenarios. There had been other ideas about settling, in getting at the same problem, but settling the imbalance reserve demand essentially at the demand location prices, sort of trying to mimic what's done for energy and collection of imbalance reserve congestion revenue that way. But the team decided that implementing this would be simpler to do and gets at the same quantity just in a different fashion. So then on slide 18, in terms of the congestion revenue collection and distribution, the previous slide discussed the quantity of what we're calling displaced congestion revenues using those calculations on the previous slide. How the ISO would actually go about collecting this congestion revenue is by adding this component to the existing imbalance reserve cost allocation. So as we sort of talked about earlier this morning, congestion contributions to transmission constraints in an EDAM BAA from resources in other EDAM BAAs will contribute to the congestion offset of the EDAM BA where the congestion occurs. Essentially, a short way of saying that is to say that if you have congestion driven by a resource in a you're a BAA that's procuring imbalance reserve from another BAA, and in doing so creates congestion in the BAA that you're buying it from. The BAA that's purchasing the imbalance reserve would be allocated the cost of the congestion created in the other BAA for that supply. Now, how this congestion revenue, once collected, is distributed is based on how the BAA and the EDAM determines that congestion revenue distribution. So for the California ISO BA, that congestion is distributed through the CR balancing account, where CRs can be funded through this pot of money and excess amounts returned to load. And then for non-CAISO BAs, the ISO would collect this revenue and return them to the BA for distribution to its participants according to their OAT processes. So essentially giving this revenue back to the BAA for distribution, however, their OAT requires them to do that. Final slide. So part of the process is sort of, for the CAISO specifically, there's a two-step process that's required because of the CRR system that we use. So one, just by collecting the congestion revenue and allocating it to CR balancing account does not necessarily ensure that the CRs that are held by CR holders actually can take the value of this quantity. So you actually need to have two separate steps here. One is the collection of the congestion revenue, as was demonstrated in the previous slide. This one is actually an update to what's actually the financial value of the CR itself, or the notional value is I think the tariff term to describe that. And the ISO would have to redefine the notional value of congestion revenue rights to incorporate the marginal cost of congestion differences between source and sink for both the energy and for the imbalance reserve deployment scenarios. Otherwise, the CRs would not benefit, the CR holders would not necessarily benefit from this collection because they would only be, CRs would only be otherwise paid on the energy congestion. So the ISO would have to make these redefinitions in the tariff to redefine how the CRs take value to include the imbalance reserve deployment scenarios. So that's my final slide on this topic. I will pause for feedback or questions.
Just confirming, Silas, do we have any questions in queue?
There are no questions in the queue at this time.
Thank you.
Okay, we'll move on to the next topic. Okay, so we're going to transition into a topic to discuss an idea that was introduced in the latest proposal regarding a transitional, what we're calling an RA true-up mechanism, or in otherwise a settlement mechanism to assist in the true-up of RA contract settlements or any other long-term settlements through this process. So response to stakeholder feedback that, of course, the introduction of new products and redefinition of existing products changes the way that these products are settled between counterparties of long-term contracts that may have assumed, have certain assumptions about what these products are and how they're settled in their contractual language. And so there is a need for essentially a mechanism for allowing parties, if they're interested in using this functionality, to use the ISO settlement system as a mechanism to perform those settlements if they don't want to do that bilaterally. Now, to be clear, one thing that's missing from the slides I should have added is this is in addition to the request for the ISO to provide information that is relevant for RA contract or long-term contract settlements that the ISO would still commit to doing, so that if entities, if RA buyers and sellers wanted to bilaterally settle these things themselves, the ISO would still provide the information that they need to do that without opting into the settlement mechanism. Now, it's our understanding that for some load-serving entities within the CAISO, they may not have the resources or the means to do these bilateral settlements with their counterparties. That's why we're offering sort of this transitional mechanism through the CAISO settlement system that would not be done bilaterally. So essentially, entities choose, both parties opting in, both the buyer and the seller opting in to have imbalance reserve and reliability capacity payments that overlap with RA capacity to be trued up through the ISO settlement system. So we'll talk about a little bit what that means. But it is important to be clear that in this mechanism, you have to have willing participation from both parties to sort of agree to use the CAISO settlement system in this manner. So in terms of how you have RA capacity and you are a buyer and seller that chooses to engage in this process, how are these things compensated? So that's what we're calling opt-in RA capacity in this slide. So for opt-in RA capacity, the ISO will compensate the load-serving entity at the respective imbalance reserve capacity price minus the opportunity costs portion of the price, and or the reliability capacity price, depending on if the agreement is in respect to both products or one or the other product. So essentially what that means, well, I won't get ahead of myself. Then if the RA resource will be compensated for the same overlapping RA capacity at the respective imbalance reserve opportunity cost, which is essentially saying that even if there is an opt-in mechanism, this opt-in process would still compensate the RA supplier for the opportunity cost portion of the imbalance reserve payment. And so if there was disagreement about whether or not that portion was applicable to the specific contract, parties would have to work that out on their own, because this opt-in mechanism is would only return the non-opportunity cost portion of the imbalance reserve price to the load-serving entity. Now, for compensation for non-opt-in RA capacity, or in other words, the buyer and the seller of the RA contract have not agreed to opt into this mechanism, the ISO would continue the settlements process as is stated in the paper for any other resource with which the supplier would receive the respective marginal imbalance reserve price and the marginal reliability capacity price if they don't elect. So of course, if parties wanted to, parties may still have to make bilateral arrangements to settle these according to their contract, but this is describing that for all RA capacity that's not considered in this opt-in process, they're essentially paying the suppliers the full imbalance reserve price and reliability capacity price as the default settlement. Now, over the term overlapping RA capacity shows up a few times, so we want to discuss how exactly that works. essentially what this is intending to mean is that you any given resource may have RA capacity and non-RA capacity. So one of the benefits of this type of mechanism compared to, say, an inter-SC trade type mechanism is that the CAISO can actually easily determine portions of products that overlap with non-RA capacity, in which case the supplier would be entitled to the full payment, in which parts overlap with RA capacity. So essentially what we do is that we take the resources set of awards from the day-ahead market, that'd be energy, AS, imbalance reserve, reliability, capacity, and we'd stack them up into, let's say, a vertical bar where you'd have energy and AS, imbalance reserve, and reliability capacity awards summed up. And then you would compare that quantity to the shown RA value that comes from CIRA in the CAISO system. So say, for example, you had a resource that's selling 250 megawatts of RA, and they have 250 megawatts of awards from the day-ahead market. Well, then all of those awards would be considered RA capacity according to this stacking. So where this gets into, so what this enables us to do is that if you have a resource that's partially RA, partially non-RA, let's say part of the resource is contracted with a CAISO load serving entity, part of it is contracted with SMUD or LA or some other non-CAISO entity. This stacking would allow us to identify the portions of these awards that are not associated with the RA capacity that's shown in CIRA, and therefore is a more accurate way of accounting for that issue. Of course, when you do this stacking, any portion of the awards that stack that overlap with the RA capacity for imbalance reserve and reliability capacity awards would be subject to this RA true-up mechanism if the buyer and seller opted in to do that. So if you had some segment, let's say for reliability capacity, if you had some segment of the reliability capacity that was above or below the RA value, then it may be the case that some of that doesn't get compensated through this mechanism because some of it overlaps with non-RA capacity. Okay, and then finally, the distribution of overlapping RA capacity. So you could also, not only can you have resources that have RA and non-RA on this capacity on the same resource, but you can also have resources that are selling RA capacity to multiple load serving entities. And so the CIRA system has that information. It has ties the resource to the load serving entities and the quantities that are shown for RA. And those values would be the way we would determine RA capacity for this purpose. Essentially, the ISO determines if you have multiple BAAs contracted with the same resource, essentially the punchline is the second bullet that you're going to first determine the portion of the day-ahead awards that overlap with RA capacity, and then you take that portion, and then if you have, let's say, for a simple example, you have two load-serving entities both opting into this mechanism, and both of them are contracting with 50% of the resource, then this mechanism would take 50% of the imbalance reserve and reliability capacity payments and give it to one LLC and 50% to the other. So you can imagine any type of pro rata split where it could be 90-10 or 70-30 or 20-20, 20-20-20, depending on how many resources there are, the process would enable to split that between multiple parties. This would have been another shortcoming of an inter-SC trade type process where in order to accommodate this in an inter-SC trade process, we'd have to expand the functionality of inter-SC trades to include some sort of pro ratio or pro rata split of the reserves. By doing it this way, we can, we think, solve these issues more easily. So in reflection, let me share sort of a summary of why we think this is beneficial. One is that for parties that want to opt into this system, this is an easier way to do it on their perspective because inter-SC trades require daily submissions. This doesn't require that, so it's sort of a set it and forget it. Once you've entered into the agreement and opted in, the ISO settlement system continues to do that daily and gets those RA capacity values through CIRA automatically, so that these resources don't have to every single day go in and submit NRSC trades for that portion. So it should be easier from the participant's perspective. For the ISO's perspective, it's also easier because the NRSC trade functionality doesn't need to be expanded, which requires more work than this. Of course, this is additional settlement work, no doubt about that, but it's seen as an easier process to implement. And so for the ISO's perspective, it's more straightforward to build this functionality than the NRSC trade type. And finally, I'll say that in respect to an NRSC trade type idea, you still have the same concepts where it's an opt-in from both parties, so that remains the same. It actually can provide more tailored functionality than the NRSC trade option would otherwise do. So it can actually make potentially the settlement process more accurate and more useful for the entities that want to use it. So we think it's a win-win-win, and we're interested in hearing entities' feedback and questions about this process.
Testing.
Noah Tom from Middle River Power. Can you talk about how often the opt-in would work? Is it a once a year, or is it a once a month? Any sort of your thought process?
Yeah, it's a good question. It's sort of a TBD in terms of the actual process. That sort of thing would have to be developed. It is easier. Let's just put it this way: it's easier for these values to remain as static as possible. That being said, I imagine what the process might look like is sort of a city-driven election where you submit a city ticket to say, there might be some sort of affidavit that we create where it's going to say supplier and load serving entity have mutually agreed to enter into this opt-in capacity or opt-in settlement mechanism for some amount of time. Maybe that's an indefinite amount of time. Maybe there's like a 6-month or 1-year transition period that they want to agree upon. So there's really a lot of different options, but we would want it to be, we imagine that during this process, there's going to be some turnover of RA contracts that may, maybe when you have existing contracts, it requires this sort of thing. And when RA contracts are either renegotiated or resettled because they expire, new contract language may be incorporated into those contracts that negate the need for something like this. So I could imagine that if that were the case, one would want to demonstrate to ISO, I no longer need this functionality when I used to need it because my contract settlement is different now, and I don't need this. So all in to say, the process is sort of TBD. We would want it to be flexible enough to accommodate sort of the changing nature of these things. And so I would imagine it could be, and James Lynn should chime in, but I would imagine that, even going down to like a monthly basis may be possible to say, yeah.
So my thinking is it's really just about how long and as far as term for contracts go that the ISO is thinking about that would apply to this, right? Because RA capacity is not simply sold on a 12-month basis,
right?
Or multi-year. It's sold month by month and or even by day because of substitute capacity. So just trying to figure out all the layers and of the granularity of this thing and how many legs it has and where it might need to stop for purposes of simplicity.
Yeah, that's a good point. So I would think that the process would need to build in the flexibility to take into account those things. But one thing that this procedure improves upon relative to the NRSC trade idea is that because these values come from CIRA, your RA values, they fluctuate monthly, but the contract, I don't know exactly how contracts will work in this regard, but if you desire, if you maintain a contractual relationship, it's just that the RA values are fluctuating month by month. This procedure can automatically incorporate new RA values for the month through CIRA and through the CIRA process. such that you don't have to, otherwise in the inter-SC trade type functionality, you'd have to be making constant adjustments to not just by month, but probably by day. And in consideration of all the other contracts that that resource may be on, it's all sort of streamlined in this process. So I see that as an advantage, but we also want it to be flexible enough to be actually useful.
So James, this is James Lynn. Since the anticipation of this is that it's going to be coming from the monthly showing, the original thought is that the election lowest granularity would be monthly. And I understand within the month there may be substitutions, but the concern is, or the problem is, that the substitutions are not coming through as shown on the LSC's RA plan. It is a substitution between generators, and we may not have that link via doing the association back to the original LSC monthly showing. So at the moment, the visualization is that the lowest granularity would be monthly, and then any substitution would have to be handled outside of the settlement system.
Thanks, James. And you actually reminded me of an important point that it's not on the slides as well, that the ISO still maintains that there does not exist a one-size-fits-all solution for this issue because of the complexity of, as James said, one of them that is not addressed is RA substitution. That's not addressed through this. So in those cases, there may require some amount of, even if parties were to opt into this process, there may be some amount of settlement going on bilaterally. There's just no way, and there's every contracts are unique in the sense that some contracts may require one thing and not the other. For example, the assumption that's going to be made in this process is that the RA buyer is or the RA seller is retains the opportunity cost value of the imbalance reserve product, because that's more energy compensation. At least that's one way of thinking about it. Whether or not your contract agrees with that assumption is a contract by contract thing that we could not possibly build in the flexibility to handle perfectly every case. So go ahead.
Yeah, I think one more piece is as you know, for buyers, sometimes they become sellers, and so because they're buying 100 megs of capacity, but then sell 3 megs to somewhere else, that chain, the daisy chain, gets more complicated as well.
Yeah, so in all to say that it will not, we don't expect this will to negate the need of outside procedures, but should reduce them, hopefully. Question, there's a question behind you. Yep.
From Cal CCA. Just first, thanks for considering this issue and putting this idea forward. We really appreciate it. I just wanted to ask about, I think on the first slide for this topic, it talked about it being a transitional mechanism in place for 3 years. I was wondering if you could explain the rationale behind that.
Yeah, so this is something relatively new in terms of what we put in. I don't know how wedded we are to the 3-year date. I'd let James weigh in on, from his perspective as sort of the business owner of this process, what it might mean to have a longer period or not. James, do you want to comment on that?
So the 3-year transitional period was due to the fact that we are introducing this initially because of load serving entities and CPUC stating that their contracts don't cover products like imbalance reserve and potentially reliability capacity up or down particularly, and how to settle that with the RA contract. And we would anticipate over the 3-year period, and whether or not it's 3 years on the nose, that can be discussed, that we would expect that the contracts would be modified to now account for this, and then you would have your own mechanism as to how to make it a more accurate true up between the RA contract and the LSC.
Okay, thanks, James. Yeah. We'll go back and think about the 3 years itself, and whether that time frame would cover the existing processes in place or whether another time period would work better. I just worry about, having to renegotiate contracts, and that possibly leading to increased costs given the way the RA market is right now and RA market tightness. So I would be interested in your all's thoughts if you've looked into that at all. But that's just my concern with relying strictly on renegotiating contracts after a certain point in time. So thanks.
Yep, thank you.
Okay, so for those on the phone, if you have any questions, please raise your hand at this time before we move to the next topic, unless we don't have any more questions in the room. We are on slide 24, so 25 will be the storage slide, right? So just a reminder for those on the phone line, please use the raise hand icon. Thank you.
Okay, so I think we've exhausted questions on this topic, and this was my last slide to present. So I will introduce Gabe Murtaugh. We're going to start on storage changes. So Gabe will take it from here. Thank you.
Hey, okay, good afternoon, everybody. Yeah, so we did add some detail into the paper on storage resources, and I think traditionally we had always had a section on storage, but in light of the work that we were doing and how important imbalanced reserves are, I think we've expanded the scope of the changes that are relevant to storage resources. So I think where we're at is, and this is a summary of what's in the proposal right now. There's 3 different topics that are covered in the Day-Ahead Markets Enhancements paper. The first topic is that storage resources will be participating in RUC going forward. Over the last few months, we've had some comments from stakeholders, and then there's been some internal dialogue and some dialogue back and forth with the Department of Market Monitoring about what the current rules state today about storage resources and their participation in RUC. And just a little bit of a spoiler here is that today, basically what we do is we just take the results from the day-ahead schedules for storage resources and insert them and use those in the RUC process, and there really is no bidding or incremental schedules that occur in RUC for storage. Number 2 is that we're going to make some small changes to the ancillary service state of charge constraint. So this is that constraint that's in the market that ensures that storage resources have sufficient state of charge to provide whatever ancillary service they've been procured for. And this includes or will include for the proposal imbalance reserves. And frankly, number 2 is something that's been included in the proposal for the policy for a long time. So several previous iterations of the paper have included this. Number 3, so I would also just add that number 1 is new policy. Number 2 is existing. Number 3 is also new policy. This is a little bit more complex. We did broach it a little bit with the technical description that was published in December, but I think we're giving a more fuller proposal of what we mean when we say envelope equations. And basically what we're doing is we're sort of coming up with a hypothetical or an estimate of what an upper bound for stated charge could be and what a lower bound for stated charge could be. Of course, we're still tracking what we believe our actual stated charge is. And effectively, what these constraints are meant to do is ensure that there's state of charge available for resources that are providing imbalance reserves in our market, and making sure that they're going to be there and available to deliver those services. So let me get into this. So the first topic is storage resources and how they're going to work in the RUC process, or the residual unit commitment process. Taking a step back, what are we doing? The day ahead market is running, it's clearing, and when the day ahead market clears, it includes virtual supply and virtual demand. We run an additional process behind the IFM process and RUC process. And the RUC process is stripping out those virtuals, and it's ensuring we have enough generation on the system to meet forecasts for every hour in the day ahead market. A resource, you could potentially think about like a gas resource on the system. Maybe it's not committed in IFM, when we're running our typical market process. But once we strip out virtual supply and virtual demand, that specific resource is needed, and it's the most economic resource to fill the gap. So when we go through the RUC process, we can commit that resource. Residual capacity process for commitment decisions. When we are going through the RUC process, we're investigating bids for capacity, not bids for energy. So the bids are coming in dollar per megawatt terms. And we're really thinking about incremental energy on top of schedules that are determined in the IFM market. Most of the resource adequacy capacity is required to bid into this process, and they're also required to bid in that incremental capacity, so incremental megawatts here, in each additional hour when they've been scheduled in IFM at a $0 per megawatt bid. So you could potentially get incremental schedules from your resources, and those incremental schedules could potentially offset the need to commit some of these resources, which of course commitments can be very expensive, because once you're committing a resource, you might have to pay no load costs, you might have to pay startup costs if their full costs aren't covered in the market, which is probably why they weren't started in the IFM process to begin with. And this is sort of what I just alluded to a minute ago. Essentially today in our market, what we do is we run the market power mitigation run first, we run the integrated forward market second. We take the results from the integrated forward market, so all 24 hours of schedules for every single storage resource in the fleet, and we just copy those schedules directly into the RUC process, and they're not allowed to have incremental schedules, incremental or decremental schedules in RUC. They're just used and they're fixed. So you can imagine the feedback that we've gotten from stakeholders, well, some stakeholders, has been, okay, you've sort of got this situation set up where most resource adequacy resources are supposed to be participating in RUC, but storage resources, which traditionally haven't been a very big portion of the grid, haven't been super impactful, aren't participating at all, really, aside from their IFM schedules. So maybe it's a good idea, if you really want to get efficient schedules coming out of the RUC process, to include flexibility for storage resources there, because if you commit one additional storage resource and it prevents the commitment of, or you schedule a storage resource and it prevents the commitment of a very expensive resource, you could be improving on efficiency and be getting a more economic output by doing that. So I think some of our thinking has been that, well, gee, if you do have storage resources participating in the day ahead process, just in general, including IFM, you are typically seeing schedules for storage resources coming out of that process where storage resources are being scheduled where prices are lowest for charging, and then they're being scheduled for discharge energy during the hours when prices are highest. This is consistent with sort of the economic goals of the scheduling coordinators who are operating and scheduling the storage resources. I think it's also consistent with what the needs are for the ISO. Obviously, prices are going to be lowest when you have your lowest net load curves. it could be times when you have a lot of, well, it's always times for nearly all days of the year when you've got a lot of solar generation on the system. That's traditionally all 12 months when we have our lowest prices, and then you're usually seeing the highest prices during the evening net load peak hours. So those are hours when solar may be coming offline, so there's not very much available, or solar may be completely offline in the evening. People are coming home, lights are getting turned on, heat or air conditioning is getting turned on, those kinds of things. And that certainly is the time when we see the greatest need on our system. And then you know, the financial goals of the scheduling coordinators for the storage resources would be, you know, to have that opportunity for arbitrage where they can buy energy at low prices on the grid and then sell energy at high prices later in the day, and utilize, you know, the 4-hour battery that they have on the system. Yeah, I've already touched on this a little bit, but borrowing storage resources from the RUC process, you know, could potentially result in inefficient or uneconomic outcomes. You could easily come up with a scenario where you potentially didn't schedule a storage resource in IFM. Maybe it's bidding at, let's just say, $100 spread between buying energy and selling energy, and the actual spread that materializes in the IFM market is, you know, let's just say $50. Well, the market's going to say, gee, this resource isn't economic, and if I actually did run this resource and schedule it to charge and discharge, it would potentially lose money. And in that case, I'm just going to schedule it not to run. And then because that storage resource didn't run and you've just copied that schedule for effectively 0 megawatts into the RUC process, there could be a potential to act for, you know, for the RUC process to actually start a resource, and if that resource is expensive, or at least more expensive than the marginal loss from the storage resource, you'd be less well off by not having flexibility to change the schedules for the storage resources, or at least have them scheduled for capacity in the RUC process, and you're paying additional money for commitments for the more expensive gas resource or any other resource. Yeah, today, you know, the way that the RUC market works is, you know, you get a schedule, you know, let's just think about a traditional resource. You get a schedule for the resource, and that schedule comes from the IFM market. And then if that resource is a resource adequacy resource, there's an obligation to participate in the RUC process up to the resource adequacy capacity. And there's also an obligation to bid into the RUC market that additional incremental capacity between what you're scheduled for in IFM up to your resource adequacy amount of megawatts at a $0 per megawatt bid. So if you are a resource, effectively what that means is if the RUC process wants you for additional capacity, it can schedule you there. And then if you are scheduled in the RUC process for additional capacity, you then have an obligation to bid that capacity into the real-time market. Non-resource adequacy capacity may submit bids into the RUC process, but they're not required to. Yeah, we've got the bidding requirement in real time, and then you also, yeah, so what are we proposing here in the paper? And I think this is outlined, you know, this is what we say in the paper. I think this is the first time we've introduced this, so, you know, I think this is kind of where we stand right now, and we did have quite a bit of internal discussion around this, but I think this is at least a reasonable first step for dealing with storage resources into the RUC process. So I think the first part of the proposal is that we do require storage resources that are shown for resource adequacy to participate in the RUC process. However, what we're not going to do right out of the gate is require that incremental capacity for those resource adequacy storage resources be bid at a $0 per megawatt value. What we're going to ask is, you know, I think what we're going to do is say that storage resources can bid as they wish into the RUC process. So if they really do want to reflect, you know, potential costs from being scheduled and requiring bids in the real-time market, you know, they can, there can be a description of that in their RUC bids in the markets. So it's effectively, resource adequacy storage capacity and non-resource adequacy storage capacity will be allowed to participate in RUC. Resource adequacy capacity will be required, and both resource adequacy and non-resource adequacy capacity for storage resources will be allowed to bid any value that they want to, and they're not required to bid the $0 per megawatt value that's a requirement for other resource adequacy resources. So, and then the other question that we got, and this is, there have been a few conversations about this, but it's sort of like, well, if you're thinking about a construct where you are requiring storage resources to participate in RUC, or they may be participating in RUC if they're non-resource adequacy, how do you ensure that they still have state of charge if you're potentially scheduling them for capacity in RUC? And I would just add that the same constraints that we enforce throughout the day-ahead market are also going to be enforced in the RUC process. So there's a there's a constraint that impacts their state of charge. That's going to be observed and constrained in the RUC process, and in fact, that's already built into RUC today. And then things like the ancillary service state of charge constraint, those are also observed and enforced in the RUC process. So effectively, even if storage resources do receive incremental schedules in RUC, those schedules will still observe state of charge limitations and requirements for ancillary service state of charge, those kinds of things. I think this is the last slide I have on RUC. Any questions in the room? Not seeing any. I think there's a few on the phone.
Yeah, let's go ahead and unmute Callie Wells.
Hi, it's Callie Wells with WPTF. Can you hear me okay?
I can, Callie.
Okay, great. So actually, I just have a couple clarifying questions on this piece. So in the paper, you indicate that storage resources can also submit bids in the RUC process to charge. Obviously, there's a bid floor in the RUC of 0. Are you envisioning that still any bids to charge cannot be price negative? And I guess in a follow-up question, would RUC actually give them an award to charge so that if they are given a RUC award later on, it's able to do so given the state of charge constraint? I'm trying to wrap my mind around the charging and discharging schedules that might come out of RUC. I guess there's two questions there. One, the bidding, and two, how those schedules would work.
Yeah. So you could, you could think about incremental schedules, right? So you could potentially be scheduled to charge in the IFM market, but RUC could potentially award like incremental capacity on top of that charging award, and that could frankly be, a charging award, but to a lesser extent, or potentially, get you into the discharging range. So I think any of those outcomes are possible from the RUC process. But as I was saying, if the RUC process did schedule you for incremental energy, and that incremental energy maybe caused you to charge less, we would account for that in the state of charge. And we wouldn't, the 24-hour optimization for RUC wouldn't put you in a situation where you would be required to bid something that would violate that state of charge. So for example, if you weren't charging as much in an hour in the afternoon, let's just say you weren't charging at all during that hour in RUC, but you were in IFM, and you had a full 4 hours of discharge later on in the day, maybe that limits you to 3 hours of discharge later in the day or something like that.
Oh, okay. So are you no longer copying their day ahead schedules into RUC? So you could actually end up with almost a RUC schedule that's completely different than IFM. Am I hearing that correctly? Like if, for example, they were scheduled to charge for, I'm just going to 4 hours straight, middle of the day, discharge, only 3 hours in the peak. If RUC, it says, just kidding, I only want to charge you for 2 hours middle of the day, are they going to, then they're not going to be able to meet their day ahead discharge schedule.
I think it's possible.
Am I understanding that correctly?
I think what you're saying is possible, but I do think it's pretty unlikely because RUC is really looking at, do I need to commit more resources? So we're saying yes, it's possible to back down storage schedules or back out storage schedules, but during those hours during the middle part of the day when that could be the case, you're probably not needing additional generation from storage to the point that you'd be backing out schedules for discharge later in the day. You'd probably prefer to have that discharge later in the day.
Okay, then just two more quick follow-up questions. So I guess back to the bidding. So even if they're bidding to charge in RUC, it still is subject to the floor of 0.
I'd have to look into those RUC rules, but if the floor is 0, I think the bid floor would still be 0 for the application for storage resources.
Okay, and then RUC, from what I think I understood you explain there, RUC could, I guess, let me phrase it this way. Could RUC ever send you a schedule to charge more than your IFM? Because I think what you walked through always indicated that RUC will only schedule a storage resource to charge less because you were talking incremental capacity.
Yes, it's possible.
Okay. All right, that's all I had. Thank you.
Yeah, you're welcome. Thanks for the questions. Okay.
Dave, I think George has his hand up. George, did you want to comment?
Oh, just on Kelly's questions regarding RAC. So maybe we should clarify this. RAC is a separate pass from the FM. So you don't have the ability to co-optimize the RAC products, which are reliability, capacity up and down, with the FM products, which is energy schedules and balance reserve awards. So when it comes to charging or discharging, my assumption is that you meant energy charging and discharging, right? That's the way I interpret it. So once IFM is complete and publishes the energy schedules, RAC will only procure reliability capacity up or reliability capacity down with respect to that energy schedule. So it will not change the energy schedule of the storage, so you won't have additional charging or discharging per se from what the IFM optimally scheduled. However, you can consider, maybe you're thinking of the reliability capacity down as an availability product for a potential charge in real time. Maybe you see it that way. So in that way, yes, there could be a reliability capacity down award for a storage. I wouldn't call it though charging because that may be confusing, right? This is, you will have a bid in real time to charge, and that bid could be called, could be dispatched if it is in the money, but it's purely a capacitive award, right? So I'm not sure exactly if you were referring to charging as the ability to charge in real time, Kali. And the bids for reliability capacity up and down, these are your normal capacity bids. Yes, there cannot be negative prices on those. You have to bid a non-negative price for getting an availability award, either in the upward or downward direction. Thank you.
Yeah, unmute Callie so she can respond.
Yeah, hi, George. Yeah, thanks. I know it's always tricky to talk RUC for storage, state of charge, because with that, it's implicit there's charging and discharging, which is energy. So sorry for the confusion. I was just really trying to understand the fourth bullet here and what exactly it's going to look like, because if you have these state of charge constraints in RUC, then in my mind, that means that RUC is going to see additional charging and discharging of these storage resources, even though, yes, it's capacity awards, I get that. So I was just trying to understand that fourth bullet and how maybe the state of charge of a resource in RUC might change due to the reliability capacity up and down awards. That's all I was getting at. But yeah, I understand it's hard to talk state of charge, which is energy, in RUC, which is capacity awards. But I appreciate your response. Thanks.
Okay, and I think Gabe will cover the constraints in more detail in the next few slides. So yes, RAC will still have state of charge constraints so that it will make sure that the reliability capacity awards that will be the outcome of the RAC process are still feasible with respect to the state of charge that the resource has coming out of IFM. So you still need to have, for example, some state of charge above the minimum to support some reliability capacity down award, based on what we're going to discuss in the next few slides as what I call them attenuation constraints. Some people call them envelope constraints, but we'll get into that.
Okay, yeah, I guess it's just their ability to submit a charging schedule in RUC. If you can, when you go through those examples, if you can kind of show where that comes in and how that would affect your constraints, that would be great.
All right, we have another question on the phone. Let's unmute Alva.
Can you hear me? Am I unmuted yet? Let's see.
Yes, you're coming in, Alva.
Okay, great. I actually want to follow up on what Callie was talking about because first of all, I think you should think about this question of the zero bids because the RUC bids are used differently from other types of capacity bids in that they become surrogates for energy bids in the RUC process. I think Callie was alluding to that. Therefore, if you have a zero bid on the charging side, which you're trying to show you're as unwilling as possible to charge, for example, then you could have essentially as I'm not sure if I'm getting it at the issue. At any rate, think about the relationship between the capacity seen as energy and the schedule that's going to obtain out of that, because I think that zero on the capacity for charging is of concern. And the other element of that I wanted to ask about is, so let's just suppose that your only need is for incremental capacity from a battery. But in order to get that incremental capacity, you have to have some charging in RUC, and there will have to be charging in order to support the ability to bid that in real time. Is there some element of the charge?
Oop, Alva, I think we lost your audio.
Silas, can we go to Kathy Wong while we wait for Alva's audio to connect?
Kathy Wong has been sent a prompt to unmute.
Shoot.
Alva, are you still there? Oh, okay, let's go to Kathy Wong and then we'll come back to Alva. I'll send him a. Oh, Alva, do you want to try again? So there you go.
Yeah, I'm sorry, I was disconnected. My internet was disconnected. Can you hear me now?
Yeah, we can. Go ahead.
Okay, the whole thing I was asking about is if you get an upward RUC award for discharge, is the downward support for that came about in RUC, is that part of the RUC award? Because it's not really upward RUC capacity and it's not downward RUC capacity. I'm thinking of a case where there's only a need for upward RUC in a particular hour. How are you treating that, the charging part of that schedule in terms of bidding requirements?
Yeah. Yeah. So I am actually regretting not including any of the examples of the constraints that we've applied in RUC in the slide deck here. We have examples of how the envelope equations are going to work, but not of how they're going to work in RUC. It's just in the IFM market. So Alva, I think I'd want to think about your question a little bit more, and I think it's aligned with the questions that Callie was asking, and it's probably worth expanding on this a little bit and putting in a little bit more detail into the I don't know what we're calling it, but the revised final proposal for day ahead market enhancements. But I think these are good questions, and I think to George's point, we wouldn't be adding incremental energy schedules, we would be adding incremental capacity schedules, but there has to be energy there to allow for those capacity schedules. Right. But let's work that out. Let me put together some examples, and I'll include that in the final iteration of the paper.
Yeah, that's great. And I'm just uneasy about you requiring charging bids that you're not paying for. And I hope you heard my earlier point, which is also, I think, Callie's point about zero bids on RUC capacity when they're being used to represent charging is very troubling if you can't represent an arbitrage between charge and discharge properly on those bids. It's of a concern.
Yeah, let us think about that. Like I said, I think this is a new aspect that we introduced since the last version of the paper, and yeah, it might be worth tuning some of these points here just to make sure we're not putting something out there that's not going to work.
Thank you so much, and thanks as always to Callie for raising these kinds of points.
Agreed. And frankly, I'll just tip my hat a little bit because Callie was one of the first people to come to me and say, "Oh my God, do you know what's going on with storage resources in RUC?" And I said, "No, I don't." So I do appreciate that, and Callie and WPTF have really been encouraging there, and they've helped us out a lot on these issues.
Thank you.
Okay, looks good. Okay, so let's move on. This is frankly the easy subsection here. This is storage resources and ancillary service stated charge constraint in the day ahead market enhancements. And frankly, I don't think this has changed in like 3 or 4 iterations of the paper, and I don't think it was one of the more interesting aspects of the paper to begin with. So I'll just breeze through this one slide that I have here. Today, there are tariff requirements that ensure that storage resources have sufficient stated charge when they're providing ancillary services. So in the day ahead market process, for example, if a storage resource is awarded, let's just say 100 megawatts of regulation up, there's a constraint in the market and the tariff requirement that says that that resource has to be able to deliver that full award for a full 1 hour period. So for a storage resource, that would mean that the actual resource would have to have 100 megawatt hours of stated charge so that it can deliver, the full 100 megawatt award for regulation up for that full 60-minute or 1 hour period. The day ahead market enhancements policy really doesn't come up with anything that revolutionary here in this regard. Basically, what it says is, in addition to ensuring that we have sufficient stated charge to provide regulation up, regulation down, spinning reserves, and non-spinning reserves, let's make sure we have enough stated charge to provide imbalanced reserves as well. So we've got these 2 equations here, the 2 terms in green, IRU and IRD, or imbalanced reserve up and imbalanced reserve down, are the new terms. And basically this just says, make sure your actual stated charge is sufficient to provide at least 1 hour of imbalanced reserves if that's the award that you're receiving. So same sort of thing that I just walked through for regulation. If the particular storage resource receives 100 megawatt award for imbalanced reserve up, make sure that storage resource has 100 megawatt hours of stated charge if you're going to make that award in the day ahead market process. I don't anticipate questions here. I'm checking. Oh, there is. Okay, yeah, let's bring them on.
Let's unmute Alba.
Hello.
Hey, Alba.
Just a quick point here, which is I just want, because you're constraining more and more the need to essentially meet this ASSOC potentially with energy dispatches specifically to, you're going to currently with regulation, you flag any dispatch that is needed to meet this constraint as being ineligible for bit cost recovery. And there was a plan, and I just want to make sure this is sort of in line with this in terms.
Uh-oh. Alva, we may have lost your audio again. Yeah, Brenda is suggesting if you send a comment into chat, we could read that out, and if you do get your audio connected back up, we'll get you back through. Any other questions, Brenda? Okay. Nothing in the room. We just flag me down if you need me in here. Okay. All right, so I'm glad. Well, let me look at the time here. Yeah, we're just about 2 o'clock, so we're still running well ahead of schedule, and I think, frankly, we're at the meat and the potatoes of the new changes to the day-ahead market enhancements related to storage resources. It's the envelope equations, and I think I'll try to get through my slides, which kind of outline what the envelope equations are, why we have them, what they do. And then I have a few examples, and I did include a few examples in the paper of a hypothetical resource and how envelope equations would impact that resource. And then, and I'll run through maybe not every single example that I included in the paper, but I'll run through a few of those examples here in the slide deck. And then George has actually gone through and developed a little mini Excel optimization to just do sort of a 4-hour example of how you might use these equations and how you might get awarded energy imbalance reserve up and imbalance reserve down, and what these constraints impact and how they might change the outcomes of the market. And he'll go through that at the end of the presentation. So, one of the things that we referenced in the final proposal for the paper was that imbalance reserves, imbalance reserve up or imbalance reserve down, is certainly going to have an impact on the stated charge for storage resources. And we actually got some feedback in the comments and through a couple of public meetings where stakeholders sort of raised their hand and said, gee, if you know you're going to have an impact on stated charge and you're not accounting for it, aren't you just setting yourself up for failure, or maybe putting yourself in the direction of failure if you don't account for these in one way or another? And of course, the problem is if you award a resource imbalance reserves in one direction or the other, and they don't necessarily have stated charge to cover those imbalance reserve awards, then, and this actually materializes in real time, then you could potentially get yourself into a situation where you're counting on the imbalance reserves, but the storage resource just simply isn't there to provide the service. And I think, we talked a lot internally with our operations team. We talked a lot internally with, the market analysis and validation teams. And I think, these comments that we received really hit home. And we thought hard about what we could do and what we're doing for ancillary services. And I think what we landed on ultimately is that, yes, we agree, we definitely do want to account for imbalance reserves, and we don't want storage resources to get unlimited amounts of imbalance reserves. And particularly, we're concerned with hours where maybe you get a lot of imbalance reserve up and a lot of imbalance reserve down. And that, if that happens hour after hour, you could easily get yourself into a situation where you wouldn't be able to provide one service or the other. And you might think that that would be more true on days when we're relying heavily on imbalance reserves, which are probably the more challenging days to meet our needs on the system anyway. So it could really be, it could really put our operators in a potentially very bad place if we did go forward with this. And then, on the other side, the thing that's always in the back of my mind is, a couple of years ago, we didn't really have a whole ton of storage on the system. Today, we're getting close to 5,000 megawatts on the system. That's probably going to jump up considerably over the next few months as we get into the summer. And then next year, there's going to be even more capacity online. So once we actually get the imbalance reserve products online, we're really talking about a pretty high reliance on storage resources on some days. And if they're not there, to provide energy or imbalance reserves on the days that we need them, it could result in serious problems. So we do need adequate tools to protect against outcomes where we can't deliver imbalance reserves. So what are we thinking about here? So enter in these envelope equations. And, frankly, this is something that George, he touched on this in one of the meetings that we had a few months ago. I think it was a presentation for the technical appendix for the day-ahead market enhancements paper. But we didn't really include these in a formal proposal. And now they're here, and this is what they are. So there's this term, the first equation is a term, and it's sort of the upper envelope of what we think state of charge could be, or what a good estimate of an upper envelope of what state of charge could be. And what it relies on is the state of charge, or the upper envelope of state of charge from the previous period. And then you're adding or subtracting energy schedules. So if you get a schedule to charge energy, your upper envelope would go up. If you get a schedule to discharge energy, your envelope would go down. And then you're adding a term that includes IRD, which is imbalance reserves down. So if you get an imbalance reserve down, that's potential energy or that's a potential award that could be converted to energy in the real-time market, and that could potentially cause your resource to be more charged up than you would have thought it could be charged up if it just received energy awards. We also include the ADA-I term, which is the resource-specific round-trip efficiency for the storage resource. So for lithium-ion batteries, you're usually thinking about like an 85 to 90% round-trip efficiency. So that's what that value is. And then you've got this other term, the AIRD, which is a multiplier or an attenuation factor on the imbalance reserve down. So it's basically some value between 0 and 1, and it says, okay, how much impact do we want the imbalance reserves down to have on the upper envelope of state of charge? And of course, what we're doing is, and this is the constraint that's enforced in our markets, we're ensuring that this upper envelope for state of charge never exceeds the actual physical upper operating limit for state of charge for the storage resources in our market. So we're saying, okay, as long as that upper envelope is below the actual physical limitation of the resource, then we're probably in a state where we can deliver this imbalance reserve. And it really does hinge around what that multiplier term, or the ARDT term, is in the equation. So the second equation is the lower term on the envelope. Very similar. You use the lower term of the envelope from the previous period. You add the energy schedules from the current period. And you also add the imbalance reserve up, in this case, award for the current period as well. There's also a multiplier attached to the imbalance reserve up award. That's the AIRU sub T term. And we're always ensuring that the lower bound for the envelope is above or greater than or equal to the actual lower physical operating limit of the resource. So the SOC with the underbar there. So yeah, I think the nuts and bolts of this are that the upper envelope is impacted when the storage resource is awarded downward imbalance reserves. The lower envelope is impacted when the resource receives upward imbalance reserves. And then both values are impacted when you receive an energy schedule. So if you're actually scheduled to charge or discharge, that's going to impact your state of charge. And then you have to keep both of those values, the upper limit and the lower limit, and of course your actual state of charge term, in between the upper and lower operating limits of the resource. And then we've got the multipliers, which we'll talk about some more in a few slides. Oh, well, this slide, here we are. So the proposal sets the multipliers initially at 0.2. I think, in some of the examples we're going to run through, we use a multiplier of 1.0. So that's sort of the most extreme attenuation factor we could have. And then obviously the other extreme would be a 0 attenuation factor, which would essentially be that we're not enforcing these constraints. They would never bind because you would only use your actual state of charge. And we think 0.2 is a conservative value, and we mean conservative in the light of it's probably underestimating how much impact imbalance reserves will actually have on state of charge. And it's probably underestimating those values on days when we really need imbalance reserves. So maybe not all days, but certainly on days with high need, this could be a bit of a low or a conservative estimate because you're only converting 20% of your imbalance reserves to actual energy in the real-time market. You'd think, yeah, on a typical day, maybe that's about right. Maybe that's about how much you convert regulation or something like that to energy. But on a day when you're really leaning heavily on imbalance reserves, maybe one of those 95th percentile days, so the upper extreme, you'd certainly be converting a lot more of those imbalance reserves to energy. But we don't have while we don't have any experience with actually awarding imbalance reserves, and we certainly don't have experience with the interaction between imbalance reserve up and imbalance reserve down and storage resources and how that might impact state of charge. So what we want to do is just kind of make this conservative assumption to start with, and then give ourselves a chance to do some of the analysis, see how the imbalance reserves, allow storage resources to get these awards. And then once we have more experience with how imbalance reserves actually impact state of charge and the ability of storage resources to provide these services, or hopefully the case isn't that they can't provide the services, but to provide these services, then we can update these multipliers as we go forward, and be, come up with critical values and think hard about how we should come up with those values. So what we plan to do, and this is the commitment that we're making here in the policy, is that we're going to document this process in our business practice manuals. So this is something that we're not going to just set it at point 2 and then forget it. This is something that will take active engagement from the stakeholder community and from our ISO data analysis teams. But we're going to be looking at the actual performance of storage resources once they get into the day-ahead market enhancements, and they have the ability to provide imbalance reserves in both directions, and find out kind of what the impacts of those awards are on state of charges. So in our business practice manuals, we're going to include a methodology for sort of the data that we're collecting, what we're looking at, and why we're looking at it. And then we're also going to include what the actual multipliers that we're using are. So you can have that as a reference. So anytime you want to look, okay, are they all 0.2? These are hourly values. So you'd have 24 values for imbalance reserve up and 24 values for imbalance reserve down. Are they all 0.2, which is sort of where we're planning to start with these values, or have they changed? And then we're going to have some documentation on why they change and frankly, how we're going to change them going forward, or how we should think about changing them going forward. Question in the room.
1, 2, 3.
Hi, Steve Keen from Edison. Yeah, I'm a little concerned with this discussion where you're talking about using a conservative number of 0.2, whereas in the transmission, looking at transmission constraints and those deployment scenarios, you're looking at 0.975. So, on the one hand, if storage is providing the imbalance reserves, you've got, two things where you're looking at, okay, what's the likelihood that this will happen? And here you're saying, oh, it's not going to happen very often. We're not going to use up most of this. But on the other hand, you're saying, oh, we're going to look at the transmission as if it's always going to be used. And I just see kind of an inconsistency in that. And I'm not sure, I'm not sure what that means, especially if this means that when you get to that 95% level that you've reserved the transmission capacity for, the storage isn't there because you don't have enough, you're well beyond where your the storage's capacity. I don't see how those two work together. It's like, you can't actually get to the 97% level that you're looking at in the deployment scenario, because when you get there, you're not going to have enough storage. So you're going to have to use different resources. So it's like, I just see that as an issue. And I realize that, we're looking at two different things here, but I think we do need to step back and look at kind of the whole picture. And I see that as a potential problem.
Yeah, I think that's a good comment, and we'll definitely think about that. I think what we're specifically thinking about for storage is, at least to begin with, we want to give the ability to the storage fleet to actually get some of these awards, and we want to observe that in the market and how the awards are actually being converted to energy. Um, because if we never get any experience, it's going to be really hard to update these terms. But then once we do have some experience, there is going to be some work and some effort on our end on thinking critically about how we want to set this number. And I think you're right. I think 0.2 is probably a little bit too low. But if we set it on the other extreme at like 1 or something, 1.0, that's the most restrictive we could ever make this, and it might restrict imbalance reserves to the point where we'd never see, any, they'd always have the state of charge to be able to provide the imbalance reserves. So we'd never see any situations where they potentially wouldn't be able to provide them, and it would make it tougher for us to figure out what these parameters really should be. But I appreciate your point. Did you have a question? Oh, okay.
Oh, we
One
do.
on the phone.
Yeah, we do have one on the phone, and then we'll take the first phone call first, and then the other two hands. So Silas, go ahead and unmute the number phone line.
Hi, thanks. This is Kathleen Colbert from Vistra. Can you
Go
hear
ahead.
me?
Yes, go ahead.
Okay, great. Hey, Gabe, I actually raised my hand back on the AS data charge constraint. I apologize, but I think it's not going to detract. I can tie it to this. Back on slide, slide 32, I think, where you show the equations. So I just wanted to flag one. I noticed, I thought I heard you say that you did not think this was new policy, but this is new policy as far as I'm aware of. Do you mind just clarifying if you meant that this isn't a change from like last version? Is that what you were trying to say? I got a bit confused.
Yeah, this is certainly new policy, which is why we're talking about it here. It's not new to the day.
Right.
This has been included in previous versions.
Okay. Okay, that's helpful. Thank you for clarifying. I got just a tad confused if there was something I should have been aware of outside of Dane. There's also, I didn't hear you explain the rationale for the 1 multiplier in the AS data charge constraint. I know that CAISO has a reason for why you believe 1 is needed for the BOW requirements, but can you explain why you arrived to 1 for the AS data charge constraint?
Yeah, I don't know that we put a whole lot of detail about this in the paper, but we do have effectively a 1 multiplier applied in this equation to reg up, reg down, and the reserves. And I think our kind of alignment here would just be to also include an imbalance reserve up term and an imbalance reserve down term with a 1 multiplier, because it was consistent with the other ones. And that's consistent with the reliability standards. But I don't think we really thought
Yeah,
beyond that.
I understand you have that rationale for the ones that are tied to a reliability standard. But the imbalance reserve is not, which is something we talk about a lot, to kind of, fed into other parts of the DAME policy. So I think you're going to need a basis for the 1, just to flag that. It would be helpful to at least better understand, and have that documented or discussed somewhere. The other thing that I would flag is this is the idea of incorporating the 1, especially for imbalance reserves, into the AS data charge constraint is pretty far away from what we had been talking about as we were arriving towards this revised final proposal. So I'm disappointed to see it not include a multiplier that's kind of based on what we think is the usage that could be tuned with experience as well. The other thing I'm disappointed that I don't see is a state of charge term proposed change, which I really expected to see. And can you explain why that's not in here?
What specific changes were you looking at or thinking about?
Yeah, the ones that we shared with you, that would the same as, you know, how energy storage enhancements takes the state of charge and it included in that the regulation up and regulation down awards, so that the state of charge term that feeds into these constraints is reflecting that, so it results in more feasible awards. As we had mentioned, it's important that the balance reserve is also factored into that calculation. So it's the combination of the state of charge term being updated to include a balance reserve up and balance reserve down with some multiplier, similar to how we are moving forward with regulation, as well as it being fed into AS stated charge constraint, ideally with the same multiplier. So those rationally work together, like really important parts of the market that needs to occur. I have a follow-up question trying to figure out if you're trying to somehow get towards that with this envelope equation, but I mean, those were the requests, right? The state of charge term be updated to include the imbalance reserve, and the AS state of charge constraint include the same multiplier.
Yeah.
And I know that there have been conversations and proposals and equations floated offline, but the rest of the stakeholder community doesn't have the benefit of that. So I wanted to make sure there was transparency.
Yeah, so you're right. There is a equation that we use that governs state of charge, and that equation was updated in the energy storage enhancements policy. It includes, you know, it basically says sort of the same things as our state of charge, the envelope equations. Let me just pull those up here. It says, well, your actual state of charge, or your estimated, you know, modeled state of charge equals your state of charge from last period plus or minus your energy awards. And then we do include regulation awards and their, you know, system averages on how much we think reg up and reg down will impact state of charge for a particular hour for the resource. Yes, you know, you and I have talked offline with others about potentially expanding that equation to include imbalance reserves, potentially up and potentially down. I think one of the major drivers for the policy that we've outlined here is that we want to ensure that storage resources effectively don't get awarded. You know, let's just say, you know, if you were to be awarded 24 consecutive hours of imbalance reserve up, even on, you know, a day where we weren't relying on imbalance reserves, you'd likely get to a point in real-time operation where you're providing imbalance reserves up hour after hour after hour, where you just run out of state of charge and you can't provide the product anymore. So I think from our perspective, our biggest concern is trying to guard against a scenario like that, where, you know, the resource is receiving a lot of IRU or IRD awards, and you just back yourself into a situation where you can't deliver it anymore. And that's what these equations do, the envelope equations. And that's primarily why we are implementing them. And I think to some extent that was, you know, also the driver for why we wanted to include reg up and reg down in the actual state of charge equation. So we, you know, I think part of what you're getting at is we're mixing and matching a little bit. You know, we've got sort of one solution to deal with reg up and reg down, and then we've got a different solution to deal with imbalance reserve up and imbalance reserve down, which is what we're proposing here with these envelope equations. And, you know, what's going on with that. And I think we're, you know, willing to say that we've got two different solutions. I think we're also willing to say that, you know, in future policy, we may want to look at and think about, gee, are the envelope equations working a little better? Is the state of charge equation working a little better? And do we need to come up with like a single solution to solve this issue? So, you know, I'm definitely aware that this is floating out there, and this may be something that we need to address in the future.
I'm also flagging that there's still the gap that we've raised and others have raised on with, there is a fear that the day-ahead market might result in infeasible or inefficient awards for storage. And that does include looking at it on a single hour basis, as well as on a multi-hour, which is what the envelope equations are getting at, is continuous usage, hour over hour over hour, right? I understand that you're flagging two different issues for two different types of products and then trying to address them with two different solutions, but it is hard to then think through and have confidence that there isn't the same concern for those products in the T time period versus the T plus one time period. And if we just need to be really mindful about making changes to the market, knowing that there are issues that have been raised for one product that we don't believe exist for another, and articulating it incredibly clearly why you aren't concerned with the imbalance reserve needing to be in the state of charge term, and with the regulation is not in your envelope equation. So that's also, yes, very confusing. Why there isn't a concern of hour over hour over hour, because we know that's not actually true, right? Because we talked about that in energy storage enhancement. And the solution that, the third solution, if I can add to the table, was that regulation cannot be provided by more than 2/3 of the state of charge capability of the battery. And so, yeah, that needed to be discussed. Is okay, is it regulation plus imbalance reserves? I hope this is helpful for transparency, but I also hope you hear me, and I hope others will join in asking you, please don't try to advance these. There's a lot more work that is needed to be done, and a lot more conversations, and hopefully they can happen in a public forum going forward, but these are not right for prime time.
Okay, thanks for the comments.
We do have one more, J.K. Wang. Your line's unmuted. Go ahead.
Hello, can you hear me?
Yes.
Okay, thank you. Hi, Kate. I have a quick question. So for the envelope SOC and the ancillary service constraint, are those two sets going to be implemented simultaneously, or it's one or the other?
Simultaneously. So these will be in the market and enforce as constraints at the same time that the other equation, the base state of charge equation, will be included as well.
Okay, and another clarification. So on the page that you're showing, this energy charging and discharging, they are decision variables, right? So they are to be determined. Okay, I see you're nodding. Okay, great. So this is my initial reaction, maybe wrong, but I think it worth to double check. There's three types of products: the imbalance reserve, energy, and ancillary service. They are all co-optimized at the same time. And you have the imbalance reserve appear in two sets of SOC equations. I understand the second SOC is the envelope, but it's co-optimized with energy. So energy is going to affect the actual SOC. So you see what I'm saying? So basically there could be a either called a redundancy or a double factor in these two constraints that could affect the determination of imbalance reserve at the same time. And you may need to do some combination of the two sets.
Correct, yeah. And actually, we'll get George on here in just a minute, but George is going to run through a very simple Excel solver that he's built that kind of illustrates how different bids and different materialized prices imply different trade-offs and outcomes from the market. And I think it illustrates exactly what you're pointing out here.
Okay, that's really helpful. And then also, I just want to reiterate what just Kathleen said. So to determine the multiplier, especially when you determine it to a lower end, less than 1, because the energy is also co-optimized with imbalance reserve here, it is possible that when the value is set lower than it's supposed to be, which is the actual deployment amount, there will not only be the infeasibility of the imbalance reserve awards, but also the energy schedule awards. So this is something to be very cautious about.
Yeah, I think both are valid points. You could easily have an imbalance reserve award that gets converted to energy that leaves you with a depleted state of charge, which means you can't, follow energy schedule later in the day. So I agree with you.
Okay, thank you.
Gabe, we do have Sergio Duenas from CISA to just quick remarks on. Go ahead, Sergio, your line's unmuted.
Hi, can you guys hear me?
Yes.
Excellent, thank you. Yes, good afternoon. This is Sergio Dueñas from the California Energy Storage Alliance. I wanted to echo a couple of the points that were made by Kathleen from Bistro before. The main one being, I think stakeholders benefited greatly from the discussions in the Energy Storage Enhancements Initiative around all the potential, modifications to the state of charge calculation formulas, and that, fostered understanding among the stakeholders of how those formulas work, and it would be very useful to build upon that and to, use that to include the impacts of this particular initiative by going back perhaps to this idea of the envelope equations. I think that some of that learning, it's not being used, not being taken advantage of. We're really needing to start from different point, different starting point to understand what are the effects of this with other formulas, with the potential, as it was noted in this last comment as well, for unfeasible schedules of other products as well. So we'd really appreciate, if either considering some of the alternatives that are in line with, proposals that have been stakeholdered a bit further, or give this a little bit more time for parties to understand, provide feedback, and generally improve upon. We understand that it's a compressed timeline you guys are working on, but really we should not make that urgency, the enemy of policy that is evidence-based, that it's aligned with the goals of the initiative, and also really that it incorporates, the feedback and the perspectives of the stakeholders closer to it. So really appreciate the work, but would love to have you consider these points too. But thank you.
Thanks, Sergio. I definitely appreciate that feedback. Okay, I think there are no more questions on the phone, and I don't see any here in the room. So let's get into the examples. This is so what I tried to do is kind of use the same sort of framework that we used in just exactly what Sergio was talking about in some of those very lengthy kind of deep dive discussions that we had in energy storage enhancements, and kind of leverage at least the backbone and the process of what we did there here in this initiative as well. But essentially, let's just make an assumption, easy working assumptions, so we can kind of see how this constraint actually works in the market. So let's say you've got a storage resource and it has an operating range from minus 100 megawatts to positive 100 megawatts. The minus 100 megawatts represents a energy charging award, and then the positive 100 megawatts is similar to a typical 100 megawatt award for energy that any resource might receive that's providing energy to the grid. We'll assume a 4-hour battery. I think that's a fairly good assumption because that's most of what we have on the system. So if you've got a plus or minus 100 megawatt resource, that means the energy limits that it's going to be working within, or the bounds, are going to be from 0 megawatt hours to positive 400 megawatt hours. And we'll just assume, again, the most simple case we possibly can, the storage resource has 100% round trip efficiency. So when it charges 10 megawatt hours during 1 hour, it can discharge 10 megawatt hours later. Again, like I mentioned earlier, we typically think about lithium ion resources, which is predominantly what's on the system, as having a round trip efficiency of high 80%, maybe something like that. And let's just also assume we need an initial condition. So let's assume the initial condition is 200 megawatt hours. So it's starting right in the middle of the range of state of charge. So 50% charged. We're also going to assume, for simplicity, not the simplest, but maybe the second simplest example. Let's use a 1.0 multiplier. So let's set the multiplier at the extreme end. And this is basically the most restrictive that these envelope equations can be. And we're basically going to be accounting for the full impact of imbalance reserve up or imbalance reserve down. We're saying, gee, if you converted all of this imbalance reserve up or down award into energy, how would that impact the upper or lower envelope of your resource? Okay, so let's do the top box here. The simplest example we can come up with is, okay, let's just say hour ending 0, this is our initial condition. We're starting the resource with a state of charge of 200. So that's sort of that middle column on the right. And what that means is if your initial condition for actual state of charge is 200, you're also going to set your upper state of charge limit and your lower state of charge envelope limit to 200 megawatt hours as well. And then in hour ending 1, and we have to abstract away a little bit, because what the day ahead market is actually doing is it's co-optimizing all of these products across all 24 hours. We're just going to assume that it did that co-optimization, and during the first hour, for whatever reason, it's awarding the resource 100 megawatts of imbalance reserve up, and it's not reserving the resource any energy. It's not awarding the resource any imbalance reserve down. So in this case, the imbalance reserve up award impacts the lower state of charge envelope equation, and it's going to reduce it from 200 megawatts, and it's going to assume, because of the 1.0 multiplier, that it fully impacts that lower envelope. So it moves the lower envelope from 200 megawatt hours to 100 megawatt hours. The upper state of charge envelope and the actual state of charge don't actually change, because there was no imbalance reserve down award and there was no energy award in the system. The second example, also pretty straightforward, is, okay, this time I've got an energy award to charge the resource. The award is for 100 megawatts. I'm also at the same time getting an imbalance reserve award up for 100 megawatts, but I'm not receiving any imbalance reserve down award. In this case, again, we start in the initial conditions for state of charge at 200 megawatt hours. And then next hour, what we're showing is, or the state of charge at the end of the hour would be an upper envelope of 300 megawatt hours. And that upper envelope is impacted by the energy award in this case. And then we've also got a state of charge that's increasing from 200 megawatt hours to 300 megawatt hours. And then because we still don't have any imbalance reserve down award, or we don't have any imbalance reserve down award, so our state of charge, the upper envelope limit for state of charge has increased to 300 because of the energy award, and the lower limit of the envelope has increased as well because of the energy award. But then it is further reduced by 100 megawatt hours because of the imbalance reserve up, just the same as it was reduced in the previous example by the imbalance reserve up award. But in this case, it just stays at 200 because the energy and the imbalance reserve up award have canceled each other out. And then there's no impact aside from the energy to the upper envelope equation. Yeah, Stephen.
Maybe we already went through this and I just missed it, but what happens if storage is awarded a ancillary service award, either regulation up or down, or spinning reserves or non-spinning reserves. And that's what I'm seeing as, the two sets of equations aren't the same. They're not including, you have the one state of charge where you're looking at the ancillary service state of charge, but that doesn't include energy for one thing. So you're not looking at what the energy changes might be. And then when you have these, the envelope equations, they're not counting any state of charge or anything for ancillary services.
Right.
So I don't know. I'm not sure either one of them is getting the full picture. And I apologize because I wasn't part of that storage enhancements, and maybe I missed something there.
Yeah, I think that's along the same lines of the comment that Kathleen made. Is we've sort of got this one methodology where we're calculating state of charge, and you're right. If you receive a regulation up award or a regulation down award, we would include that in the impacts on state of charge. And we've just assumed here, very simply, that we're just not getting any ancillary service awards. But you certainly could have ancillary service awards on top of these awards, which would impact state of charge, but it wouldn't impact the upper or the lower envelope limits.
Okay, but I guess that's what I'd like to see would be an example with that in there, because it seems to me that in some of these cases you could get to a situation where you're not violating the envelope awards or the envelope equations, but basically you've got a situation where it doesn't have sufficient energy to provide the AS that it's supposed to be providing.
Yeah, and those are, you're right. Yeah, we could certainly work up some examples where we're thinking about an ancillary service award in addition to imbalanced reserves.
Okay, thanks.
Yep. Okay. So, and these are in the paper too, and I tried to give a little bit of color in the paper, and I did include like a sentence on whether or not the ancillary service state of charge constraint would be violated. And in this case, because we're enforcing a 1.0 multiplier on the upper and lower envelopes, the ancillary service state of charge constraint is always met. But as soon as you have a multiplier that's less than 1.0, it might not be. But I can include some examples of that in the next iteration of the paper. Did we have a question on the phone? Yeah, let's go ahead and take that too. Jonathan, I think you're unmuted if you have a question. Maybe.
Yeah, so just want to clarify, do you envision storage resources being able to have both ancillary services and imbalance awards and or energy all at the same time?
Yeah, all of the products are going to be co-optimized across all 24 hours. And we will have scenarios where storage resources receive combinations of the products in any given hour and certainly across the day.
So if a resource gets received an award for regulation and it's going up and down all over the place, how is that going to be able to provide IRU or IRD?
Yeah, so imbalance reserve up and imbalance reserve down are capacity products. The ancillary services are also capacity products. So you can't have, traditionally when we think about, can a resource receive energy awards? Well, let's just think about a gas resource. Can a gas resource receive energy awards and ancillary service awards like reg up? Yes, it can. If it's a 100 megawatt resource, you could get a 50 megawatt award for energy and then a 50 megawatt award for regulation up. And then
as long as it's within its regulating band, yes.
Yeah, as long as it's within, yes, of course, yeah. And the same is true with storage resources. You could get an award for energy in the upward direction. You could get an award for regulation up. And then in the same way, we're adding an additional product. So we're saying you could get an award for energy, you could get an award for imbalance reserve up, you could get an award for regulation up. So all of that would be possible. And the market, and this is part of what George is going to show, is going to co-optimize all three of those products. It's going to procure, it has requirements on how much it needs to procure during each hour, and it's going to procure those at the least cost across the entire system for each of those 24 hours.
All right, thank you.
Yeah, it's good question, and I think that sets up some of the context for some of the conversations we're going to have when George takes the stand, the podium here, virtual podium. Okay, great. Oh, green is go. Oh, we've got a great signaling system here inside of the room for questions. Okay, so I'm going to run through these examples. Yeah, do stop me if there's a problem or an issue. I think we're going to do the corollary of the example that we just did. So the resource gets a discharge award instead of a charging award, and then that discharge award happens to be coupled with a downward imbalance award at the same time. So the downward imbalance award and the energy award both impact the upper bound of the envelope. So the upper bound of the envelope stays at 200 megawatt hours. The lower bound of the envelope is only impacted by the energy award. So the discharge of 100 megawatts brings the state of charge down from 200 megawatt hours to 100 megawatt hours. And then obviously the energy award impacts the state of charge and reduces that from 200 megawatt hours to 100 megawatt hours. The thing I would note here is that, you know, the really cool thing about the envelope equations are that the state of charge is always going to be bound by the upper and the lower envelope. So if in this case, the lower envelope equation or the lower envelope state of charge is 100 megawatt hours, the upper envelope is 200 megawatt hours, the state of charge is 100 megawatt hours. It always, it falls in between those bounds because of the way that it's set up. Okay, so the final example here is an imbalance award in the downward direction and an imbalance award in the upward direction. And I think I've messed up my notation here. So unfortunately, I've got a mistake in the slide, but this should say 100 megawatts of imbalance reserve up and 100 megawatts of imbalance reserve down. But it looks like I've done a different example where I'm discharging 100 megawatts or charging 100 megawatts and got 100 megawatt of imbalance reserve up. And that's what we see in the state of charge. But you can imagine a situation where we are, so not what's on the slide here, but a situation where we do have 100 megawatts of imbalance reserve up and 100 megawatts of imbalance reserve down. That's going to impact SOCU and SOCL, but it's not going to impact the actual state of charge. The actual state of charge stays at 300. The upper envelope state of charge goes up to 300. The lower envelope goes down to 100, which sets us up for the next few examples that I'm going to run through. I'm going to keep going here, and this actually might be, I don't know if I've included a few more examples in the paper, but this is sort of just an additional kind of set of examples of what could happen for outcomes for resources that sort of don't get awarded. So this is an award you wouldn't see in the market. So for example, let's just take that last scenario that I outlined, which wasn't correct on the slide, but is correct here. So in that hour ending 1, we get an award for 100 megawatts of imbalance reserve up and 100 megawatts of imbalance reserve down. That increases the upper envelope state of charge and decreases the lower envelope state of charge. The next hour ending 2, we get the same award, 100 megawatts of imbalance reserve up and 100 megawatts of imbalance reserve down. The same thing happens. The upper envelope increases, the lower envelope decreases, and now we've sort of got the upper and lower envelopes at the 2 extreme ends of their range. So the lower envelope state of charge is 0 megawatt hours, the upper envelope is 400 megawatt hours. In the next hour, if the resource, if the optimization wanted the resource to have 100 megawatts of energy, it couldn't do it under this scenario because 100 megawatts of energy would cause the lower envelope to be decreased by 100 megawatt hours, and you'd be in an infeasible range. The same thing with imbalance reserve down. That could potentially push the upper envelope for state of charge up above the upper bound, which wouldn't be feasible unless there was an accompanying energy award. But in this case, that accompanying energy award again pushes the lower envelope equation down. So you couldn't, this is an infeasible outcome. You really couldn't get an award for either imbalance reserve up or imbalance reserve down at this point. And the key that I want to make sure we kind of circle back to, and this is what George is going to show, is that these are all co-optimized over a full 24-hour period. So what the constraint is really doing is limiting the amount of aggregate imbalance reserve awards that the resource is getting over the full course of that 24 hours. And it's not necessarily, doing this sort of operation where it's limiting in order of hours. Brian?
Hey, Gabe, Brian Thaker with Middle River. With regard to the second line,
yeah.
Can I assume that should say no further dispatch that exacerbates the binding limit will be awarded?
Yeah.
You could conceivably get dispatch that would, push the resource back into the envelope, right?
Well, in this case, there isn't a way to actually get the resource back into the, once that envelope is kind of expanded to the maximum values, there's no further ability to move the resource around. But the market isn't solving like this where it's linear, where it's solving the first hour, then the second hour, then the third hour. It's solving all 24 hours at once. So you might, even if you got to this point even if you really got to this point at the second hour of the day, those would be the optimal 2 hours to provide the imbalance reserve up and the imbalance reserve down across all 24 hours of the day. And then that's just, that just applies to your day ahead schedule. Once you get into the real time market, you can still bid and operate, as the resource is able to. But that's a good question. Yeah, okay. Final example, and then I'll be quiet and pass the mic here. So, let's think about, we've been working on this pretty simple example where we were just talking about a multiplier of 1.0. What if you had a multiplier that was closer to the initial multiplier that we're thinking about using, which is 0.2? What that means is the awards for imbalance reserve up and imbalance reserve down aren't going to be as impactful to the envelope stated charge value. So the upper and lower envelope stated charges are, there's just going to be less impact there. So for this first example, you get an energy award for 20 megawatts, and then you get an imbalance reserve up award for 50 megawatts, and you don't get any imbalance reserve down award. Well, in this particular case, and I think this gets to some of the earlier questions, we wouldn't be able to award the resource 100 megawatts of imbalance reserve up in this scenario because the resource only has 80 megawatt hours of actual stated charge. So an award of 100 megawatts of imbalance reserve up would violate that ancillary service stated charge constraint. So effectively saying, yeah, you wouldn't have enough stated charge to be able to provide this. So in the second example, I'm showing that the resource receives an award for 80 megawatts of imbalance reserve up, and it can't receive an award for 100 megawatts of imbalance reserve up because the actual stated charge is still only 80 megawatt hours, which means you can't have an award for more than 80 megawatts of imbalance reserve up. So what you can see here is that you do when you have an award for 20 megawatts of energy in hour ending 1, that's going to decrease your stated charge by 20 megawatt hours. So you go down from 100 megawatt hours to 80 megawatt hours. At the same time, you are reducing both your upper envelope for stated charge and your lower envelope for stated charge by 20 megawatt hours. But then you're also decreasing your lower stated charge by an additional 10 megawatt hours because you've got that 50 megawatt award for imbalance reserve up, and 50 megawatts times 0.2 is 10 megawatt hours. So that's how we're updating these, and they follow largely the same logic as the previous examples. And you can kind of see, hour ending 4, hour ending 5. I'm doing the same sort of thing where I'm awarding the resource 100 megawatts of imbalance reserve up and 100 megawatts of imbalance reserve down. You can see that that's impacting the upper envelope for stated charge and the lower envelope for stated charge. Again, because the multiplier is 0.2, they're not moving at a very fast rate. They're moving at 20% of the rate of the previous example. So although we are seeing them go down, it's going to take them a lot longer to get to the lower threshold of 0 megawatt hours or the upper threshold of 400 megawatt hours. I think there's a question on the phone.
Yes, we do have JK Wang. Let's go ahead.
Thank you. JK Wang from PG&E. Hey, Gabe, can you go back to the last slide?
Yeah.
Yeah, I just want to clarify here. We have the lower envelope is less than 0 here. Is when you say that no further dispatch will be awarded, do you mean by hour 4 or hour 3?
Hour 3.
Okay, so in this case, what will happen here? Like IRD will be actually 0 or?
I was just giving an example here of sort of an infeasible dispatch. So this dispatch in hour ending 3 is not feasible. We wouldn't see the market give awards like this. And it's probably laid out a little bit better in the paper. But I wanted to give a few examples just to kind of understand how the upper and lower limits work. And then this is an example of something that the upper and lower limits would prevent from happening.
Okay, and I just want to understand, like, when the market is running into this infeasibility, do you have any insight what will happen?
So let me. I think this is actually a great segue to George Angelides, who's going to go through sort of an example of an optimization, and I think that'll directly address your question.
Okay, thank you.
Okay, so George, I currently have the screen up here. Is there anything I need to do to give you permission to work the presentation? Oh, maybe, yeah, we've got a request here in the room to take a break, so maybe that's a good idea. Maybe just like a
Sure.
break. Yeah, good idea.
I do see George. We'll test this audio and his video footage in a bit, but 10 minutes for a break. So let's meet back at here at 3. Do not disconnect, everyone. So stay online. Thank you. Okay, let's get started. Let's see if George is on so we can share his slides. George, go ahead and, if you can, share your screen.
Yes, someone. I'll do that right now.
Okay. And thanks, everyone. Thank you, Steve, for the suggestion for the 10-minute break. We have some great popcorn and cookies. So if anyone wants to join us right now, feel free to fly down here in Folsom.
Brenda, can you stop sharing?
Yes.
Gabe's.
Absolutely. How about now? Let's see. Can you share?
Yes.
Okay, confirming, George, I can see your screen, an Excel spreadsheet.
Okay, thank you. So we can resume whenever you are ready, Brenda.
Okay, we are ready.
All right. All right, so good afternoon, everyone. So I will walk through an Excel spreadsheet that uses the Excel solver where I build a model to illustrate how energy and imbalance reserves are co-optimized with the SOC constraints. Not all the SOC constraints. I'm focusing here on these envelope constraints and the basic SOC constraint. I'll describe a little bit what the model does, and then we'll see some examples. So you have a single energy storage resource, right? With I have to separate its charge and discharge. There are different bids for that. Charging bid is $10. Discharging bid is $100. So you have a $90 spread. You have a charging efficiency for all the examples I used one here, but we can set it to something else. It's a plus minus 10 megawatt resource. So the charge can go down to -10, the discharge up to 10, and it has a 40 megawatt hours, which is like typical 4-hour battery. So the SOC is between 0 and 40.
George, can you zoom in first?
Yes.
Thank you.
Say again?
Can you zoom in the spreadsheet?
Oh, yes, of course. Hold on.
Okay. That's way better. Thank you.
All right. Yeah. Okay. Now, I'm not using a binary variable here to separate the charge from the discharge. to keep the model simple. And if you have prices that for capacity products are much lower than the energy product, I don't think you'll see an outcome from the optimization. You'll have both, simultaneous charging and discharging. In our model, this prevented having a binary variable that you can only have charge or discharge. But in this model, not to keep it simple and not complicated with binary variables, I didn't put any, so won't come up anywhere in our examples. But since we will release this for your educational use, keep that in mind. You may drive the solution to an outcome that it's infeasible, where you could have both charge and discharge, particularly if the capacity prices are much higher than the energy. And keep that in mind, that this does not have the protection of an exclusive OR between charge and discharge. The other thing I want to point out here is that these are your three SOC constraints. This is the basic SOC constraint for the base scenario, so that only has the energy impact. So this SOC changes as the resource charges or discharges. And this is the upper envelope. You can consider this being the SOC in the imbalance reserve down deployment scenario, since the imbalance reserve down attenuation affects the upper envelope. And this is the lower envelope of the SOC as we track it through the time horizon. You can consider this being the SOC constraint of the imbalance reserve up deployment, because imbalance reserve up affects the lower limit of the envelope. I have 4 intervals here. 4 hours is a simple model and an initial condition, where we assume that the resource has an initial schedule of 0 megawatts and an SOC of 20 megawatt hours, so it's about 50% charged. All right, that's how it starts the day. So these are your prices, your LMPs for marginal energy, for imbalance reserve down and imbalance reserve up. So this is really a production cost simulation for the energy storage resource. We're based on the LMPs and the balance reserve marginal prices. What the model does, it optimally schedules the storage between these commodities, energy, imbalance reserve, and imbalance reserve down, subject to capacity constraints on the energy, making sure that we're staying within the plus minus 10 megawatts, and the SOC constraints, making sure that we're staying in the SOC range of 0 to 40 megawatt hours. So the objective is to maximize the profit, being the difference between revenue from the market based on the marginal prices and the solution, which is those red cells here, that will be calculated by the solver. The difference of that revenue and the bid cost as reflected by the bids. Okay, so we can start seeing some examples here. It's important to note that in the SOC envelope constraints, I consider the coefficient to be 1 because it's a small problem. Within 4 hours, you want to see the effect. With much lower coefficient, won't be able to see too much of an effect on it. And because the coefficient is 1, I don't model the other constraint, which is on the SOC that requires a specific SOC at the beginning of the interval to support imbalance reserves. The envelope constraints are more restrictive in that sense because they don't allow cancellation on that. They track the envelopes. So having those in place, I don't have to enforce the other constraint. And we will see what results we get. We'll discuss them. So that's a quick explanation about the model. We can go and start seeing some examples. Obviously, with the $10 bid to charge and the $100 bid to discharge. If your prices stay in that range, between that, then you won't have any charge or discharge during the time horizon because the resource is not in the money. And if you have in 1 hour the price drop below 10, then you'll have a charge. If it goes above 100, you have a discharge. But what is important to show for storage is that sometimes, and I need to be changing the magnification of those as we go. So here I put the charge, I put the LMPs for hours 2 and 3 to $150 and okay, hour 4 as well. So you have the ability to discharge now because there's a $50 profit for these hours on the $100 bid. And with the original SOC of 20 megawatt hours, you can do that for 2 hours. So you can discharge on hour 2 and hour 3. Then the SOC is depleted. You cannot do that for hour 4 unless you charge in hour 1. So you can see here a unique property that the storage resource has in the market, where you can charge in 1 hour, build the state of charge to support discharging in other hours. This example, I nullify the capacitive effect, so I don't have capacity bits to show exactly what happens in the energy, and then we'll make this more complicated as we add capacity. So as you can see here, the resource is charging full charge for hour 1, and it's out of the money for hour 1. It incurs a cost of $400 because its bid is $10 and the price is $50. But over the time horizon, this is still economic because by building the SOC from 20 to 30, because of this charge, now it can discharge the next 3 hours. So for the time horizon, if it didn't charge here, you would only discharge on hours 2 and 3. But now you have the ability to discharge on hour 4 at 150. So you collect $500 for that 4th hour at the cost of $400 loss for charging in hour 1. So a storage resource can actually do this trade-off across the time horizon. And this happens on your spread, on your price spread in the LMPs exceeds the bid spread. So here the bid spread between charge and discharge is $90, but the price spread here between hour 1 and 4 is $100, right? So it is economic to charge out of money for hour 1 so that you can discharge in hour 4 and still have $100 net profit out of this operation. Now, this, of course, is influenced by the charging efficiency as well. So with a charging efficiency of 1, you can right away see the advantage of taking the $100 price spread on a $90 bid spread. But if the efficiency of the resource is less than 100%, and just for the purpose of illustration here, I will make it, just half as efficient, and we rerun this, you will see that the solution is going to change, and it's not going to do that. So now you only have the discharge on hours 2 and 3 that depletes the SOC, and you are not going to be able to discharge on hour 4 because there's no energy behind it for that 4th hour, and it's not a good business proposition now to charge in hour 1 and build the SOC because full charge in hour 1 will still cost $400, but you will only build 5 megawatt hours of SOC. So you will only have 5 megawatt hours to discharge on hour 4. So now the economics are different. You're not making up for that loss. So always be cognizant on the relationship between the bid spread, the price spread, and your efficiency. I'm going to move into the next examples now, and I'm going to bring in the imbalance reserve. I'm going to open up these bids here. And just in case there are any questions on so far, I will wait to see if there are any questions to address just on the energy aspect of the storage resource and understanding the model before we go to introduce imbalance reserves. Are there any questions?
Yeah, we do have a question from Callie Wells.
Okay, Callie?
Hey, George, Callie Wells with WPTF. I guess it's not a specific question on the model and the numbers you have right now, but I guess a bigger ask. And I appreciate you putting this together and being willing to post it on the website. I was wondering if before you post it on the website, you'd be able to expand it to include the other ancillary service constraints as well as AS awards, because I think a lot of the conversation that just took place when Gabe was presenting raised a lot of questions on how all of those constraints that a storage resource is going to be subject to work together, which includes AS. So I guess our ask would be if you can expand this to include AS so we can see how all the constraints would work together.
Thank you, Callie. I don't promise. I mean, it really depends on how much time I have available between everything else that I'm doing at the same time. We can always include and expand the model. Now, there is a constraint that we're running against that. This is the Excel solver. It doesn't allow for big problems to solve. So, adding more constraints, it may push it to its limit. But, if there is time availability, I will look into that. No promises at this point. We'll see how this goes. Okay. And I was going to say, yeah, we released this this educational tool for you, but there are some caveats, and one of them was, we don't provide support or enhancements to it, and it's as is. But I will take the request under consideration. Thank you.
Okay, appreciate it. Thanks, George.
All right, no more questions, right, Brenda?
Yes, that's correct. Go ahead, George. Thank you.
So let's go to example 2, and I'm going to make it larger again. So here we're opening up the bids for imbalance reserve up and down. So we're assuming that the entire capacity of the storage resource is available for energy and imbalance reserve up and down, so that it can be optimally scheduled and co-optimized across all these products. We have a flat energy price of $50, so that's within the spread. So just for energy alone, the resource is not going to charge or discharge. Will stay at a zero energy schedule, as it happens here in this solution. And there is a price for the balance reserve products that exceeds the bid for this product. So to the extent that there is state of charge, you expect to see awards, and that's what happens here. You have both imbalance reserve up and imbalance reserve down awards that you can see for hours 1 and hour 2. And if we didn't have those SOC envelope constraints, you would see awards going in for hours 3 and 4, and effectively the entire time horizon. But because these constraints are in place, the upper and lower envelope, you can see that the upper envelope of the SOC is building up as the imbalance reserve down awards are held in this hour. So we start with 20 at the beginning of hour 1, and that becomes 30 at the end of hour 1 because of those 10 megawatt hour that are built, or the expectation is that imbalance reserve down award will be fully deployed in real time. So that will make the SOC 30 megawatt hours, then another 10 megawatt hours for the imbalance reserve down award in interval 2. that will get the upper envelope to 40 megawatt hours. So there's no more room under the up envelope, right, to have additional imbalance reserve downwards. And the similar situation happens for imbalance reserve up. So for the first 2 hours where the resources are awarded 10 megawatts of imbalance reserve up, you can see its lower envelope on the SOC now being depleted to 10 at the end of the hour one and 0 at the end of hour two. So although it's in the money, excuse me, to provide imbalance reserve up, it doesn't get an award because of the constraint on the lower envelope that it doesn't give it any room, can go negative. So this simple example here illustrates the reason for having those envelope constraints on the SOC. If these constraints were not present, you would see these 10 megawatts of imbalance reserve up and down award perpetuate through the entire time horizon. So the purpose of these envelope constraints is to bring in an expectation that these awards, or at least a portion of these awards, are going to be dispatched in real time, right? And therefore, it is unreasonable to have these awards perpetuate over the entire day, unless you have some energy schedules that are different than zero that would either charge or discharge the resource, and in this way will reset those envelope constraints to create more room, and we'll see that in some other examples that are coming up. Let's make another stop here to see if there are any questions on this simple concept before we go to more complicated examples, which is really what we're trying to show here is why we're coming up with this envelope constraints. What's the purpose? So this is the illustration of why, how they act and what we get out of them. Are we having any questions on this?
George, I don't see any questions in the room.
Okay. All right. We go on. So in the next example, example 3, let's see. We change the energy price, the LMP, to hours 3 and 4. We make it $150. So now the resource is in the money for discharging. So we want to see what effect that will have on the envelope constraints and the awards for imbalance reserves. So indeed, the optimal solution will have the resource discharging in hour 3 and hour 4 because it's in the money to discharge in these hours, right? And under the envelope constraints, the discharge in these hours, okay, it's depleting the SOC. So if you look at the upper envelope of the SOC, all right, in the previous example, we were going from 20 to 30 and from 30 to 40 because of this imbalance reserve downwards. And now in this example, you can see an effect where the discharge in this hour creates room under the envelope constraint to have an imbalance reserve downward. And the same happens in the next hour as well. So this basically says that if we have the expectation that the imbalance reserve down award will be deployed, fully deployed here with the one coefficient in real time, then when you discharge the resource, you create room for imbalance reserve down on it, even in the same hour. Now, I don't have the other constraint enforced here, but Kali suggested maybe we should do it as an expansion of this tool. The way this constraint is is written, this other constraint would not allow this simultaneous effect because it only has the capacity words there. This one you get a cancellation effect in the charging direction. When you discharge, you leave room for charging, and then that room can be taken by the imbalance reserve down. So you have this phenomenon here that you can have as long as the resource is discharging, right? Then you can have an imbalance reserve downward for that amount, right? Because then they work together, those two, in the envelope constraint. So you can see that the envelope constraint stabilizes at 40 and keeps going like that, right? Now, still, this is not something that you will continue seeing, right? This is not going to happen. If I had more hours here, you wouldn't see it going past hour 4. Why is that? Because you have the base SOC constraint in the base scenario that for as long as you discharge, right, it's depleted, right? So from 20 here, it goes to 10 because you discharge 10, and then it drops to 0. So in the next hour, if we had fifth hour here, you would not be able to have this pattern here because you won't be able to discharge the battery anymore. You have to charge it to build the basic SOC so that you can discharge it again. So the combination of these constraints, they give you some ability, all right, to have more imbalance reserve awards in the opposite direction of what the energy is doing, because they create room one for the other. But the basic SOC constraint that looks at how the SOC is built just for the energy, because the reward may not be deployed at all, right? So we still have to have this constraint. That will limit this pattern and will require now a different pattern to continue. So that's what you see in this example, that you have this ability for the resource to provide essentially 20 megawatts of imbalance reserve down in hour 3 and 4, right? In comparison to the previous example, just because the resource is discharging and it's in the money to discharge, so that's an economic outcome, right? So let's see. And there's no imbalance reserve up award here. Okay, you get the benefits from extending the imbalance reserve down award over 4 intervals. That's how you get the profit in this example. So this example shows a simultaneous discharge and imbalance reserve down award that could continue the pattern for as long as the state of charge, the basic state of charge allows discharge. Now we'll try to change this a little bit in example 4. And now let's see what we did here. Yeah, I turned this LMP on hour 4 to 50, so now it's not economic to discharge anymore. So that phenomenon, it's limited to hour 3, right? So it's not economic to do that in hour 4. And now that if you look at your other envelope, that your upper envelope, sorry, your lower envelope, it leaves room for an imbalance reserve upward. So now that you don't have to go to this level and have another award here for discharge that will affect the envelope, you have room for a 10 megawatt hour of imbalance reserve upward. So the optimization will pick that up and suck it up as additional revenue here for additional profit. And that's because it's not economic to have this pattern in this hour because the price is not supporting it. All right, from 150, now it's just down to 50. So you won't do it. It's not economic anymore. You will lose more money in energy than you will make up from the imbalances of downward. In the next example, we'll disturb that balance. So here, we're changing the price for imbalance reserve down and up. So instead of $5, now it's $10. So previously it was not economic to do something like that. And it's still not economic for our 4, but it's still economic for our 3. But here you don't have a simultaneous discharge and imbalance reserve down award. You have the discharge in hour 3 because it's economic, but then what you build under the SOC, the upper envelope, you see you get it from 40 down to 30, you make room for 10. It's not taken in here, it will take it in the next hour because you have a better price for the imbalance reserve down. So here, this phenomenon is not happening at the same hour, it happens across the time horizon. Again, this is on all an intertemporal co-optimization, right? So you have the ability to create room with a discharge for another 10 megawatt of imbalance reserve down award that happens on interval 4. And as we saw before, you still have room for a 10 megawatt of imbalance reserve up. Now, instead of having it in hour 1, of course, you will take it in hour 4 because the price is better, right? So that's what the model does, and that's how the constraints coordinate in that. But still, this discharge happens because it's in the money. So you expect that to happen. So we want to push the optimization to do something not straightforward. So the next example will push it to do an uneconomic discharge to benefit from the room that that will create for a capacity award and get an additional capacity award, and that's example 6. In example 6, we want to make an economic the discharging, so we reduce the price from $150 to $90. Okay, but we're also increasing the value, the price for imbalance reserve down, right? So now you'll see that the effect is to discharge out of money, right, at $90. That creates room for another imbalance reserve down award that then can be awarded in interval 4. So you have a loss of $100 for this discharge out of money, but this opens up room under your upper envelope because it pushes your upper envelope from 20 to 30, so that then you will have this anyway, so you can have this imbalance reserve down award, all right, and have some profit from here that is offsetting your loss. So the storage resource is really a unique resource that has this phenomenon where you can have participation in the market that is at a loss in a specific interval, depending on the prices and the bids, but it's done to make up for that loss with additional profit in another hour over the time horizon, so that at the end you have a maximum profit over the day. And we knew that for energy, and that was example 1. You have seen those examples like example 1 in the past. So here we'll show you how this still carries through when you optimize energy and capacity awards. So it's still possible, just because of the capacity awards, to have charge or discharge out of money in an hour, not for the benefit of energy revenue in another hour, but it could also be because of the benefit of an imbalance reserve award or a capacity award in general. So this is what I wanted to show you today. Several things: the effect of the envelope constraints that they have in the optimization. They can be restrictive, but they can also be reset depending on the economics if the resource gets an energy charge or discharge. So throughout the day, hour by hour, you have a co-optimization of all the elements, all the moving parts here. So maybe in an hour, those envelope constraints limit the awards of imbalance reserve, but that doesn't mean that it limits them for the entire day after that, because those envelope constraints are readjusting and resetting every time the resource is dispatched for energy, scheduled for energy, and that makes room for additional imbalance reserve awards or internal capacity awards, even in the same hour or in a future hour. So there are a lot of moving parts, and we'll release this tool for you to become familiar on how this play all out. Just keep in mind the caveats I mentioned earlier. Let me see if there are any questions on what we saw today.
Silas, do we have any questions in the phone line?
Yes, we do have one hand in the phone line.
Okay, let's go ahead.
Hi, this is Kathleen Colbert from Vistra. Can you hear me?
Yes.
Yes.
I just wanted to raise for you that, I want to second Callie's request from the beginning of kind of walking through this. The way that storage is represented in the market is more complex than this example captures, and the ancillary service state of charge constraint is a really critical piece of that, and it does drive the market outcomes a great deal. And so, respectfully, George, this is very illustrative. I'm not seeing a ton of value on top of what Gabe already provided, because what we need to explore is how these additional equations will interact with the AS stated charge constraint, both that exist today and as proposed under energy storage enhancements, as well as with the proposal, frankly, that the storage community has put forward. And I'll note that CISA included that proposal in their comments on the last paper. So if for the value that I think you're looking for, I do think you will need to do an updated version before you post it. So I just want to echo that and point you to some of these resources. If you look at CISA's comments, then you can see what the alternative proposal is that you could maybe compare and contrast and highlight why you think this is superior.
Okay, so I heard the same ask like Kylie to make this more complicated and add more constraints to.
I would say make it accurate so that it provides some kind of value, because at this point, I don't see anything enlightening about this.
Well, if that's the case and participants agree, then we will not post it. There's no reason posting it. That's what I hear you say, that there's no value in this, then why post it? As I answered to Kali, we'll make an effort to see if we can enhance it, and if we can, if the model allows it, because this is a simple model, right? So there are limitations. So if we can enhance it and we have the time to do that, it always comes down to time. Then of course we can try to do that. But are you actually asking me not to post it because you think it has no value? I'm not sure.
Am I still on mute? Sorry. Can you hear me?
We can hear you.
Okay. No, I'm asking you if you're going to put forward the effort to provide an example you think will be beneficial, to take the time to do that more fully. I know you're resource constrained. I respect your resource constrained. It's important to put forward a model that actually does provide some kind of value and shows how the market would, what kind of results we might expect from this proposal, which does include the energy storage enhancements changes. And frankly, it doesn't include a profit maximization objective function. So thanks for the effort. If you could take a step back and update and provide an example that looks something closer to what our market model is, then I think that will have value. I'm not going to ask you not to post this. I just think it's really important that nobody tries to use it to learn something from.
think there are a lot of things that you can learn from this, but if you disagree with me, then fine, we disagree. And as I said to Kali, we'll try to enhance it with additional constraints. But again, this is all time restrictive and capacity restricted, depending on what the model can do. We find that obviously we'll try to do it. We try to be useful to participants, and whenever we can get that, well, we will do it. But I don't promise. Again, that was my answer to Kali. This kind of tools, they're nice to have. My participation here is limited. So if I can make the time to devote more resources to this, then obviously, yeah, we will do that. So we'll go ahead and post this one because I still think it's useful. And then if we have the ability to, make it bigger and more complex, then in the chat,
Yes,
maybe
George.
I
That is
can try to address it.
Yeah, and I think Mahan actually entered the verbal queue, so if we can unmute Mahan.
Oh, okay. I think it's an example too.
Hello, this is Mohan Mansouri from PG&E. Can you hear me?
Yes.
On this example, after hour ending 2, it seems that the all both state of charge upper and lower limits are under limit. And I'm just, to me, it seems that the battery stuck there. You can't charge it because you're going to violate the state of charge upper limit and then discharge it because of state of charge lower limit. In its current state, am I mistaken seeing that it's stuck there and you can't do anything unless, I don't know, you relax this constraint? Or I heard something about resetting. I don't know, you reset it back to what the state of charge.
Energy schedule. So your state of charge in the base scenario stays at 20 megawatt hours. It's halfway charged. Because you have those imbalances of up and down awards, you have a buildup on the upper envelope that goes from 20, 30 to 40, and then a depletion on the lower envelope that drops from 20 to 10 to 0. When you reach this point, there's no more room for additional awards because the envelope constraint says if I get an additional award, then it may not be able to be deployed in real time because there's no state of charge to support it. And that's why you don't have these awards. Those constraints prevent it, right?
I understand.
Because there's 40 and 0. So the statement was that if the energy prices stay like that to $50, so with these energy prices, the resource is not in the money to charge or discharge, and the price for the imbalance reserves is low enough compared to the energy prices so that it's not economic to try to charge and discharge and reset these constraints, the envelope constraints, so that you can have imbalance reserve awards. That's not an economic proposition. In this example, this doesn't happen, right? But in other examples where we change the prices, like,
So if we change the prices, my question is, if they change the prices, the prices are, then the only, so in this example, it's not after hour ending 2, you're not on the limits. But even if the prices allows you to charge or discharge, the state of charge constraint would not. I mean, the upper and lower state of charge constraint would not, right?
No, it changes, right? So this is what happens here, right? Where we have $150 price in hour 3. Now the resource is in the money to discharge, and we'll get a discharge. So before, your envelope constraint for the upper one for imbalance reserve down, right? It was 20, 30, 40, and that 40 was limiting you, was staying at 40 because no more interaction. You couldn't award any more imbalance reserve down. But look what this discharge does. It resets it. It gives it an additional 10 megawatt hour room, right? So now you can have 10 megawatt of imbalance reserve down, and that happens in the next hour, all right? Because it's also the higher price. So here you have the that's why I have this example to show you that
Yeah, but
if the price is right, if it's economic, and you get a charge or a discharge, that resets your envelope constraint and lets you makes
but
room for additional imbalances everwards.
okay, let me show my extent. But you can discharge it because the state of charge on the lower limit is at 20. That allows you to discharge it. If the state of charge lower limit is at 0, you can discharge it. And that's the case in example 2, right?
In example 2, your state of charge stays at 20. You
No,
always
a state
have
of
room
charge
to discharge.
lower, SOCL, is
This one?
at, yeah, so there are like 3 constraints here. State of charge, so there's 2 constraints, state of charge upper and lower limit, right? The state of charge lower limit on hour ending 2 is at 0, versus the other example is at 20. So when you discharge, when it's economic to discharge, and you do it in that example, it allows you a state of charge lower because it's at 20. You discharge 10, it goes to 10. But here it's at 0. Even it's economical, you can't just discharge because it's violate that state of charge lower limit. So here, yeah, in this example,
you see, here it didn't award the 10 megawatt hour of imbalance reserve up, and also in example 5. So it makes it, because everything's co-optimized, it makes it available for a 10 megawatt discharge by not awarding the imbalance reserve down, so it's not depleting the upper envelope on the SOC. So this is possible. And also in this previous example, this is possible because you still have 10 here. Because you don't award an imbalance reserve up here compared to example 2. In example 2, you have imbalance reserve up, imbalance reserve down, so it depletes the SOC on the lower envelope, right? And you hit 0. So yes, it's not economic to discharge, but you see, but even if it was economic, it still wouldn't discharge because of this envelope constraint.
correct.
And you're correct, but if it's made economic enough, then the solution will pivot to something like this, where you won't have the second imbalance reserve up award, so it will leave you room to discharge instead, so that you can make the imbalance reserve down. So you have all these moving parts that are co-optimized, right?
Yeah, I understand the optimization could do that, but just say if you get to the point at example 2, then and that's not happening in. All right, I think all right. Now I understand the optimization looking at the 4 hours, not prevent that from happening. But I'm just saying, start at hour 2. If you move to hour 3, hour by hour, you stuck in hour 2, and you can't just move past that.
If you look 1 hour at a time, you're right. But of course,
that's right.
It's co-optimized across the horizon, and that's why you have this ability that if there is a way to increase your profit by foregoing, perhaps in this case, the imbalances of upward, so that you can have more room on the lower envelope constraint to discharge, so you make room for imbalances of down, and that's what happens in the other example. So
yes, thank you. Yeah,
the optimization weighs in the various possibilities and picks up the one that you walk away with the highest profit, right? So
yeah,
thank you. That was a very, very good comment and very illustrative here on how this would work.
Thanks.
All right, we have a question from Sergio.
Yes, thank you. This is Sergio Dueñas with the California Energy Storage Alliance. I just wanted to, I appreciate. I think the storage community definitely appreciates you providing this example of how the envelope equations could work. I think this last question and a couple of others that have been raised through this conversation sort of highlight that there's definitely still significant questions about how this would interplay with other constraints that are already existing. We understand obviously that you are constrained in terms of timing. And by that, I mean, all of the ISO staff that is constrained in terms of timing. That's why we definitely wanted to ease the lift of getting something that the community understands and that we can understand the impact of. So I do want to, urge the team to look at our comments. I think we put a proposal, an alternative proposal that just builds on the language that we've been using already in energy storage enhancements. Um, if there's not enough time to stakeholder all of this, like you guys want to do it by the May timeframe that is expected on the initiative, we can think about it. We can think of other ways or approaches to get to an end state that we can better understand the potential impacts. And I just really want to echo that statement of Kathleen. Look at our comments. I think they would ease the lift on both sides, and they align with our goals of getting something out there that is understandable, that we can foresee the effects of, and that allows us to meet some of the deadlines that the ISO is adamant on meeting. So we appreciate the work on this, George, for sure. But we would also appreciate if you put some time, you, the team, all staff really, in looking at our comments and considering their implications as well. But thank you. Yeah.
Thank you.
George, we have one question in the room. Go ahead.
And this is Steve Keen from Edison. I think that I agree with the people before that it would be important to include ancillary services in this example. But the other thing that I'm seeing here is this is assuming that prices are given. And, this is a resource that's not setting the prices. One of the things that I'd be interested in is if the storage resource is such that it starts setting the prices, or that it's the marginal unit in that in the optimizations, how does that potentially change things, and how do those how might then the constraints here interact with some of the other stuff going on? I realize it's significantly more complicated, but I at least want to have you thought about what would happen in that case, especially if storage is getting to be 5,000 megawatts. I think there's reasonable chance that it may end up being on the margin, at least in some hours.
Yeah, it's possible. Yes, Steve, you're right. This is not a market simulation. This is like a production cost simulation that, it has the advantage not to consider more complicated constraints like power balance constraints, have other resources that contribute to that, have demand. That will probably won't be able to solve with Excel. So the ability to solve it as a production cost simulation insulates you from those complex elements, and basically you make the assumption, just for the purpose of the example, that this is a small storage resource that will not affect the LMPs or the marginal prices. So you take the prices as given to drive the optimal solution for the storage resource. You're correct. If this is a complete market, then the LMPs and the marginal prices for imbalance reserve are not an input anymore, but they're calculated as a result of the optimization, which will now be a market simulation about how the market will operate. But then we'll have to include all the market constraints, right? We have to include the imbalance reserve procurement targets. We have to include the power balance constraint. We have to include other resources with their bids. So it goes on a different level that I don't think the Excel solver can really crack that, right? So
I would agree, but I think that emphasized one of the things that I've been considering is that when we get to market sim on this, this is not going to be kind of the normal market sim. This is going to be a market sim that's also kind of testing out everything. Normally market sim, I think what you're doing is making sure the code runs the way you think and that all the different pieces of the KISO system interact properly. I think in this case with DAME, when we do market sim, there's going to be an awful lot more, like we're talking about. That's probably
Oh,
gonna be
yeah.
the first time you get to you can actually do all this, run all
Right.
the optimizations together.
There are different stages in the market sim, right? You start by, testing, connectivity, then you start testing scenarios to make sure that the functionality works. And then at the later stage of the market simulation, you start looking at quality of results. So that's what you're saying. So basically, yes, the software works. It doesn't break. The results, are produced. There is connectivity, but do the results make sense? That comes a little bit later in the market simulation where we start looking at the quality of solution. And that is part of every market simulation. And I agree with you. When it comes to do market simulation for DAME and EDAM, there is a lot emphasis on the quality of solution to make sure that the results make sense. We should do that, yeah.
Okay, and that's one of the things that we had in our comments. Just we'd like to see that the CAISO is planning that into its implementation. That there is a large market sim with a lot of input from customers, and that you're at least considering that this is a different type of animal than usually with market sim.
Thank you.
Okay, so we are running out of time. I do see one person in chat who raised her hand, Nadia. Hope if you could do a quick question or she lowered her hand now, so that's okay. We'll take her question.
You scared her away, Brenda.
No worries, George. So thank you, George, for your explanation. We will go ahead and proceed on the next steps. And if you can stop sharing, I could go ahead and share my screen as well.
Absolutely. Thank you, Brenda.
Of course. Thank you, George. So now we're going to go ahead and just proceed with the last few slides of the presentation. So for the next steps, oh no. Oh, there it is. For the next steps, so we're going to have a comment period due on April 20th. And the comment templates available now for you to review, to add your comments, and the revised final proposal will be posted on the 28th. As well, we're planning to go to the board on May 17th, and the implementation will fall 2024. Feel free to visit the website for other updates as well, and notices will be going out for those meetings accordingly. Feel free to email my colleague Isabella Nicosia or our ISO Stakeholder Affairs group for any questions and concerns. We appreciate those who came today. And last but not least, we do have an Energy Matters blog that we are reaching out for those who are interested in. Last month, we did present on transmission interconnection. So this month will come out later on the new energy blog monthly summary. I also wanted to pitch in for those who haven't seen the notices today. We also have the ancillary services state of charge constraint. First meeting will be held on April 27th for the straw proposal. Gabe Murtaugh will be leading that, and that will be a hybrid meeting as well. So we're giving everyone like a 3-week notice on that meeting coming up in the 27th. So thanks so much for everyone for coming, and we thank our speakers and Greg, Gabe, and James, of course, for those who are coming, and have a safe travels for those who are here today. And Silas, we can go ahead and close our meeting for today. Thank you.